production grade MCP OCR server right from scratch in under 1 hour using Python, TensorRT and the model context protocol. This is not a basic PyTorch script. We are talking about an actual microservices that can take images, raw file, byte stream and return back clean and extracted text. In this video, I'll guide you step by step through how I build an open source MCP OCR server that is also getting some traction. About 2000 people have been using it and it's used by devs in real project. By the end, you'll have your own version of running it locally or even on the cloud. So it's fast, modular, async, and yes, it works on VS Codes too or even in the cursor. So stay tuned and we'll show you how I have been using it in the open source client like Grey Goose, and it was able to discover the tool and was able to perform the OCR. Stay tuned. Let's start with the implementation. We are going to initialize the dependency first. So let's do that. We'll do uv init venv. No, let's do uv init first. This will initialize the PyProject.toml, and you can see these things are being added. Now install. Let's do uv add. So for this we need MCP CLI, and we need PyTorch. We need OpenCV Python, NumPy, below HTTPX, alright, so it says an error. Let's see, let's follow the documentation. Okay, it's MCP. So now the dependency are getting installed. Our all dependencies are done. Let's look at the PyProject.toml, and we can see that we have our MCP. For creating our MCP server, our dependencies are installed. Perfect. Now let's start creating the project structure. We'll create an src directory, and inside that we are going to create the tender init, and then we'll also create main.py, and for another file which is server.py. So now we are going to start the implementation. So first thing first, let's import the dependency. Let's make a simple doc string which says MCP OCR server implementation. Here the doc string is important when you are building the MCP. For developer as well as for the LLMs. Now let's import few important things from typing. For type validation, import any optional union, because we are going to support multiple options. So now let's import CV2, import numpy as numpy, import PyTorch from mcp.server.fastMCP, import fastMCP from mcp.shared exceptions, because we need to also handle any error that is occurring. Since it is in prod code, so we'll have to make sure that the code does not break. mcp types, import error data, internal error, internal params. We are also going to import HTTPS, because user can also provide a link from internet as well. So import URL libs, because we also need to sanitize or parse the URL. enum, let's import enum. And import subprocesses to handle multiple requests. Let's import system. So once these things are done, we'll start doing the implementation. So base thing is, for this code to run, we need to ensure that the server has TensorRT. So we need to first implement a logic that if TensorRT is available or not. And let's give it a log string, check if the TensorRT is installed and accessible. So let's make a try catch. Try an exception. We'll run subprocess dot run. So this will execute the shell scripts. So we'll C double S E R A C T comma version. So doing this, I'll show you what it does. Capture output is equals to true, check is equals to true. I mean, this should be a truthy, and if it does not works, then subprocesses dot call process error, file not found error. File exists? No, it should be file not found. And then we can just, for now, let's print fc TensorRT not found, and then we will attempt to install it, because we get this exception. And that's why this is a prod level code, because we are going to do the installation as well. system.stdr. So then we'll implement one more function, which is let's make one separate file here, and this would be install. Install TensorRT.py, and inside of it we are going to implement various methods that will do the installation as per any environment that we are running this script. So let's make a dummy function right now here. So def install TensorRT, and let's pass it for now. We'll come here from install install TensorRT. From because they are in the same level. So let's come here for now. We will right away implement it, so we'll just call it install TensorRT, and as soon as this script is called, we'll make this execution. So this will ensure our MCP server will be running correctly anywhere. Now let's implement the TensorRT installation. So let's first build a package manager. And it is going to return null str, and Python is complaining, so we'll import from typing. Yes, so that's fine. And here we are going to detect the system itself first. System package manager. So like, is it using Windows or Mac, or any systems? So for that we'll have to import the platform. So now let's get the system. So platform dot system dot lower. So this way we'll get the system. Now we'll see if subprocess. So we'll also need to import subprocess. So let's check one by one which system, if depending upon the Darwin, Brew, Linux, apt or DNF, we are going to check if their bin exists, user binary exists. So now let's do installation. Let's do a simple if system equals to Darwin, then we are going to check if the homebrew is installed. because that's the easiest way to install PyTorch. So again, let's execute subprocess dot run now. So this is how you check if homebrew is installed. Which brew? So it gave me directory, this is where it is installed. So that's how we are going to do. So which comma brew, and now we are going to capture the output. Capture output dot run return code is equals to 0. This means that this process successfully executed. So in that case we are going to return yes, we have brew available. Now if system is Linux, which would be mostly servers, so we can check for the apt directory, which is, let's first check debian ubuntu. Now if os dot, so we'll also need to import os. Path dot exist, we'll check if this path exists. Slash user slash bin slash apt. If this is returning, then we are going to return the apt installation. Now we need to check if elif os dot path, let's copy it, and it is in DNF. Then we are going to return DNF. Elif os dot path dot exist slash user slash bin slash pacman. So in that case, you are getting it that we are going to return pacman. So if none of them is returned, we'll just handle the none case. Now this is where we are going to do the installation based on the system that is where our code is getting executed. So now let's again call system first. So svm is equals to platform system dot over p package manager is get package manager, the function that we just implemented, and we are going to go in a try catch loop if system is Darwin and package manager is brew, then it's a very easy we just need to execute the sub process dot run brew comma install comma tesseract. And we'll just add a check true. So this is how the system, this script will automatically install in the macOS system. Let's build it for the other systems such as Linux when the apt is available. Elif system is equals to Linux, and if package manager is apt, then we are going to run subprocess.run sudo first because we are installing the package, apt get upd will first update, and then let's check true, then we are going to run the installation. This is the best practices. So sudo apt get install. Let's also give the explicit permission -y tesseract OCR. OCR, and we're going to do check true. So same thing, now we'll repeat it for the DNF and pacman. So elif, let's copy that. This will be elif package manager is DNF. In that case, we are going to do sudo DNF install -y tesseract, because they have different naming as per the distribution. So now let's again one more time. If the package is pacman sudo pacman and then after that the command is bit different. So after pacman it will be -S, and then the confirmation is like no confirm, then you put a comma, after that it is same. Now the only remaining thing is when the system is Windows. In that case this will have to do a manual installation because Windows does not allow execute string to install the packages, because by default the security features firewall will block it. Users, but in that case we are going to print the instruction, please install which is up/mahim. So from there you can refer how it can be installed. In that case we are going to just return, and then we will before returning we'll just write TensorRT OCR, and in the exception subprocess called process error as E. So we'll have to specify what happened depending. So right now I'm just going to do sys.exit. We'll also need to import system. So once this is done, I think it is going to install. So let's now test it. Render. Let's see if it installs the tesseracts. So let's do uv run src install tesseract. Okay. So there must be some typo that I have made. So it is saying line number 31. It says platform dot. Okay, so there is two brackets that I need to. Now it is installing the tesseract. See, this is happening. It automatically detected that I am using the Mac OS and it is doing the installation. So that's how the production systems are built, packages that are built, and this way we are going to ensure our MCP server can be used by anyone and anywhere except Windows for now. But mostly all of the servers are Linux based server, so for 99% of the user it won't be a problem. Meanwhile it is doing the installation. Let's go back to server. So now our code, whenever this code will run, it will ensure that we have the tesseract already installed. Now let's start doing the implementation. Let's go to initializing our MCP server. So it says TensorRT OCR is installed successfully. Perfect. Now we can start implementing our MCP server. So now let's install the object. FastMCP, we'll name it OCR. And let's define the input type. So let's make class OCR input is an enum. So what type of input that we are going to support? So it is going to support file, URL, meaning if people can provide URL, then also we can do it, and it can also support bytes. So meaning if you have the image byte already, then you can also use it file path, then also you can use it and URL as well. So that's how, like, the flexibility that you give to your any LLM or MCP client, they whatever the data they have, they'll just send it to our server. So now let's define a sync def load image. Because we are giving this flexibility, so we'll need to ensure that we have handled it properly. So input data, this is a union, could be str or could be byte. So if it is an str, then it means this is a local path, or an it's a local path, or it is a URL. So it will return a numpy n dimensional array that we will give it to the our OCR tesseract. So let's implement it. We need to first thing determine input. This is important because we are giving this flexibility. So if is instance input data is str, and this means it means there is two things. So first we'll see if it is a URL. Parse dot URL parser, URL parser, and then we'll pass the input data dot scheme in, meaning it is an HTTP or HTTPS, because what may happen, some systems have their internal networking, so in that case they might also be using HTTP. So now if this is true, then we'll need to collect with HTTPX async client, and we'll need to, in prod we'll have to give a timeout, as client client dot get the input data. So now we got the response, and if there is any problem, we'll raise fault status, and as if there is no any error, then this line will execute, which is np numpy from buffer response dot content. We want it to be np dot uindate. So now we handle the exception. httpx dot http error, meaning we were not able to download the image, so we are going to raise an MCP error. This is important, and the error data internal error failed to fetch image from URL. This information will help any LLM to know that the URL that they have provided, either that is not correct, or they'll need to check if the URL is correct, or maybe they can ask user to validate. Now once this is done, meaning we have handled the case where it is a URL, so this, now we are going to check for another case where if it is a path or a directory, so which is pretty much straightforward. Path exist, if that is true, try an array numpy array dot from file. We are going to need input data and npy.uint. So that's how it is done. If there is an exception, except SE, now we'll raise for it MCP error, and we are going to raise error data, internal error, failed to read image file, str of error. So this will help an LLM to see what is happening. Now the basic case when it's an byte, so that will be in default else case. So this is the case when it's a byte. So nparr dot from buffer, and we are going to give input data, uint 8. Now we are going to decode the image. So we have just the numpy array, we have to decode image from it. So image is equals to cv2 dot IAMENCODE. There is a method, I know it. Sorry, IAMDecode np array comma cv2 dot image IAMRead in color. So if image is none, which is a possibility, then also we need to raise the MCP error. Internal error. Image data. And we are going, if this does not happen, then we are going to just return the image. Now we come to the exception. Exception is maybe we should do exception as MCP exception, MCP error, raise it for now, or this way. Exception is E trace MCP error data. So you will become used to of doing this, and you will also see the value of doing it, because unexpected error loading image str of error. So this way we completed the image loading functionality, and as you can see, we are handling each of the cases like URL, or is it from a path, or we are directly getting the buffer. So now let's move on to implementing the tool itself. So to implement a tool, you do @mcp mcp.tool. So that's how you define our tool. So this is going to be async def perform OCR input data. Let's give it a union of str bytes, because these are the two different types of input. And then you can also specify for TensorRT what language it is. Languages, this is str, by default we'll use English if not specified. And then the config, these configurations are for this is for actually the configurations of TensorRT. So let me do for now just this is going to be default configuration, so we'll only focus on that. Str. Now we are going to, here the docstring writing is important, so we'll have to write a descriptive docstring. So this tool perform so its args data can be one of file, path to an image, or URL, and then draw image bytes. Languages, TensorRT code default, and we will see default is the -OEM 3 PSM 6 also define the what is it returning. Returns extracted text from the image, and also we'll have to give a usage example. Now see, perform underscore OCR. We'll have to define the path to .jpg. So that's a example that you'll have to give. It will be helpful for any LLM. Let's also give one example of an image that it hosted on a web server, example.com/image.jpg OCR, and then for image byte just pass a variable image bytes. So I think these are good descriptive say argument. The definition of this function, it will be helpful for an LLM, or maybe you can refine it more within ChatGPT or anything. The main objective is the implementation here. Let's first validate the image. Validate language. So we are going to pass so that the errors are gone. Expect. Okay, so all error red lines are gone. That's how I feel comfortable while doing the coding. Now let's start doing the check of the available validate the language. So PyTorch get languages. So if languages not in available languages, if the language is not in the available language, then we are going to raise MCP error, because in that case we are not supporting that the language. So invalid parameters, unsupported, so we'll also give the information what languages are available. So this will give our client, MCP client, information that given language is not available and what other options are available. Image, await the function that we have created. Since we have handled the all cases, what possible input can be, so we don't have to worry here. Now let's try to get the text. So PyTorch dot image to string will pass image, langs is languages, config is config. So now we at this point will get the text. If not, we'll also do some validation. Stop. I mean, there can be a chance that the text is an empty string. strip. Then we are going to again raise the error. Internal error. And the error data. Sorry. So MCP error. Error data. Error data. Internal error. No text. Detected image. And if that is not true, that means we have detected the text. So return text dot strip and exception yeah, so this thing is done. So we'll handle the case where the TensorRT is not working. Internal error, OCR, and we'll also do one more exception for the outside one. Exception as E raise MCP error data internal error unexpected. There can be an unexpected error. However, you won't see that much during OCR. In those cases, we are going to give this information to the client. Now, I was also thinking we can also give the tool for the language model to get to know what languages are itself available. So let me define that. So again we'll have to define the tool. Get the list of and it will return, since there is no params, it will return the usage So let's implement. Now same thing, TensorRT TensorRT.get languages. If not langs, then we are going to raise an MCP error. Now error data, internal error, no supported languages found. Please check. Please check the TensorRT installation, and that's all. If everything is fine, then we are going to return the languages. We don't need this pass now. And if there is any other unexpected errors, so we should also handle them. Internal error, failed to get supported languages, str, and yeah, we are pretty much done. Now we just need to make the calling name is equals to main mcp.run transport is going to be stdio. So that's how you implement the server. There is one error, let me see where it is. Okay, so it should be no more errors. Now we'll just need to update the init and under main file so that the execution is very smooth. Let's come to dunder main. So we'll have to do some import arg parsers from .server, import mcp. So def main parser, arg parser, parsers. Description, let's give it a description. Extract text from images using OCR. Files URL. So now if render we'll just call the main, and now we'll need to update the init files so that all exports are done correctly. Let's also export the version. Mm-hmm. 0.1.0. This is going to be the first version. From .server, import MCP, perform OCR, get supported languages, and MCP perform OCR. So that's how the complete initialization is done. Now we just need to do one thing. In our the PyProject.toml, we need to define how to start the execution. So if you come here, you just need to define the project dot scripts and MCP OCR is going to be MCP OCR dot main, and that's how you do the initialization of this project. Now this has become a pretty much long tutorial. I will pin rest of the code if I'll put the GitHub link. If you go there, and you'll see the rest of the code is present over here, which is nothing, we just adding the scripts so that we can push this into PyPy. If you see this project, I have pushed into the PyPy, so there are some configuration steps that are needed. Why we are doing it, that I'll show you, because now once this project is pushed to the PyPy, then we are going to use it anywhere. So for using this MCP server, we need an MCP client. So let's install Grey-Goose. I'll show you how to do the installation. Okay. Sorry, it's a goose. bucket is called goose. Let's see. We can see if there are multiple one. I'm just, yeah, goose. So this is the goose. Okay, I was going to the right directory. So let's go to installation and install for Mac OS Silicon. You can use your other anything that you want, like Linux or Windows. It is available. So once the installation is done, we will do the LLM setup. So for that we'll use the free Grok. Come to Grok, do a sign up, then create an API key. So this is the key that I'm going to use, and let me just put it. Don't worry, I'm going to invalidate the API once this project is up. So I can see our goose is installed. Now we just need to do the installation. So let's see. Alright, so we have our goose has been installed. Now we'll use Grok configuration, the API key that we have got. Let's do submit, and we are good with Grok. Now we need to just see. Let's type hi, see if it is working. Would you like to talk about a specific? Alright, so let's come here and let's go to settings, switch provider. There are llama. Alright, now let's go to extension. Now we are going to, you need to click on the click custom extension, and in the extension name is the MCP OCR stdio. This can perform OCR in the images. So now it is asking for the command. So come to this. Since we have pushed our change onto the PyPy, now you just need to do UVX MCP OCR. Let's see if it works. Then this means our all setup has been done perfectly. It will take some time. Meanwhile, what I'll tell you what is happening. It is pulling it from the PyPy and doing the installation. Now because the installation also requires to install the PyTorch, so it is taking time. Yeah, so you can see our MCP OCR just got installed, and let's go in a chat. Let's ask if it is able to discover. Can you do OCR for me? Yep, look, it just takes it was able to connect to the it tried to execute those tools, but let's ask it, can you perform let's try to give it an image. Let's use this image. What is that? I think I need performance here. Let's create a new chat. Sometimes it does not work. The gray goose. We'll need to change the model. Let's use Grok. Alright, maybe there's some issue with Grey Goose, but that's how you enable it in the, this is how you start your MCP server, and it was able to connect with it. What can you do for me? I think there's some issue with llama key. What can you do? Funny. Maybe I'll need to switch some model. Configure. Switch models. Yeah, so see, it is telling that MCP OCR perform optical of images and documentation. So the MCP client was able to discover it, which is good thing. And yeah, so for the code will be available in the description of this video. You can see already I am recording this after that I have pushed. Already 2000 people have already using this project, and it's also having some stars. So you can see the people are using it, forking it. There are some open issues in the project as well. Feel free to raise a PR, and that's how you build a production grade MCP server. And thank you very much. Leave any question. Please do not forget to subscribe. Hey everyone, today we are going to deep dive into something that has been absolutely blowing up in the Python AI community. It's Pydantic AI. If you've been wondering how to build an AI agent that don't break in production, stick around, because we are about to build something seriously cool stuff together. So here's the thing, we have all been there. Imagine like you are trying to build an AI agent, maybe chatbot for your business or data processing assistant. You are using raw OpenAI SDK or maybe LangChain, for example. Like if you have LangChain, So you might all be familiar with LangChain if anyone is doing some serious stuff. So everything works. I mean, as far as the language chain, everything seems working fine until it is in the local system. But then you deploy it to production, and suddenly everything falls apart. So the what happens is, like, the responses are inconsistent. Your data validation is literally non-existent, and debugging feels like you are trying to find a needle in a haystack. So now if I told you there's a framework that's designed from ground up to solve exactly these problem. What if I told you it's built by the same team that created Pydantic, the library that literally makes every major AI framework uses under the hood? And what if I told you it makes building AI agent feels like as smooth as building an fast API application? So that's Pydantic AI, and today we are going to build 3 different AI agents from scratch, starting from simple and working our way up to production ready systems that could actually deploy and use in real world systems. So before anything, first you should come to the ai.pydantic.dev. Here you'll see the complete documentation. This is what we are going to follow, and so you should ask yourself this question whenever you are watching this video: what is exactly Pydantic AI? If we head over to their official documentation, you can see here they describe it as a Python agent framework designed to make it less painful to build production grade application with generative AI. Now the key word here is the production grade. This isn't just another wrapper around OpenAI API. This is a framework that's built with same philosophy as FastAPI: type safety, developer friendly, and reliability. So think about this way: what FastAPI did. FastAPI revolutionized the web development by making it incredibly easy to build robust APIs with automatic validation and documentation. The Pydantic AI is trying to do the same thing for AI agent. So let me show you what that makes things special. So if you can see the providers, I will head over to the example model providers. You'll see there are a lot of providers: OpenAI, Anthropic, Gemini, Mistral, Cohere, Bedrock, Hugging Face. So the models support is really good, works with all major providers. And the second core principle is the structured responses. Your AI outputs are validated Pydantic model, not just a raw string. And the type safety, everything is properly typed so that your IED can actually help you dependency injection for testing and clean architecture. And there is also the built-in observability, which is the Pydantic AI's log fire monitoring system. So you can also check log fire Pydantic. This is the one where you can do the telemetry, meaning you can trace you can have a cloud server where your OpenAI traces are all over present over there. So this is a paid services, but alternatives are also there, like MLflow traces. Tracing. You will also make one more video explanation how you can use MLflow observability. This is all some serious stuff, like this is a production stuff. So Now we'll start doing the session, and we are going to start with uh, the first setting up of our environment, where we are going to do all of our coding session. So first of all, head over to UV Astral and click on this link where it says install on Mac Linux. Copy this string and head over into your IAD. Preferably make a folder. You can paste if you are using Mac OS or Linux. You can directly paste this command. There's also options for Windows. I am using my Mac, so it is going to work for me. Now it says everything is working fine. UV is installed, so let's check UV version. So it says 0.8, which is fine. Now we are going to initialize the project. So to initialize a Python project, you should first type UV init. It is going to create some files for you. It's the git ignore main pyproject.toml readme. By default it does it all of this for you. And now we'll go back to Pydantic AI and we'll use the Grok because I want this tutorial for everyone. Grok provides free API key for your learning. I mean, as soon if you are using it for production, you'll have to purchase their enterprise license, but for learning and development, Grok is sufficient. So let me also open that. Now let's head over to the installation. We'll click on the UV command, and it is saying UV add Pydantic -AI. So what it is going to do, if you'll see the pyproject.toml, the dependency array is now empty, meaning it does not need any. This Python project is completely empty now. So before doing that, we'll first initialize our separate virtual environment. So we'll type uvvenv hyphen python. Let's specify a python 3.11. This is completely optional. If you want, you can do that, and once it is done, we'll activate the Python environment with source dot when activate. So if we see which Python, so it is pointing to our only this is the exact folder which it is pointing right now. So now we can add we can go again back there, copy this command, we can paste, and look what it does. In the dependency array, it completely populated the required dependency for this project to be run on different environment as well. So uv.log is something that you don't have to worry about. It's just there to keep a track of all of the dependencies. Now once you are done with this, let's go to Grok. grok.com. Let's go to start building. Let me do a login. So let's create an API key. This is the API key, but I am going to invalidate it after this session. Let's create an .env, and we will make a grok API key, and we can paste it over here. And since we are using the .env, we should also add the python.env. So this will make us it easier for us to do the loading of this key. So come over here and you'll see there is a template code which is written in the for you to basically see if everything is working fine. So we can just test what happened. Let's go here. Just to run a Python file, you will run main.py, and you can see this got printed, which means we are good to go. And we can also do one thing. So we'll also right now just to verify if my IDE is also picking the right environment. So there is called select interpreter. This is the environment that we want, and then we can do developer reload. There is a command reload window. So this refreshes everything. It syncs all of our dependencies. Now that we have our grok key, let's go to the grok example. So I hope that I am using the correct name. If we go there, let's see. Yeah, it was same. So now let's come over to, we'll make a separate one, which is the 001 py. I don't think so it will allow it. All right, py. So this is how you have to initialize the agent class. We are following the documentation. So it says from Pydantic AI import agent, Pydantic AI import agent, and once you imported it, we'll have to do the initialization. So the agent class we are initializing, and we just have to specify. Look, the type hint is telling us what should be the first argument. It is model equals the model string. So we'll search for grok, some model that has the capability to do the tool calls. So let's call llama models. OQ llama, actually let me copy it, versatile. So that's how you get the model, and there are like other ways as well. So one quick note here, while we are using the grok today, remember that Pydantic AI is a model agnostic, and you could swap this out with Anthropic Claude, Google Gemini, or even local model with Ollama as well. So now let's do one thing. We'll first try to see if this runs. clear and uv run o1.py. Okay, so we have to from .env import load.env. Now this should work. Yeah, so the code ran successfully. We have not invoked the agent. I just wanted to show this is how you connect your local code to any AI provider. So in the next file we are going to prepare one example where we are going to make an agent that will collect the weather information, and we will get it in a structured manner. So let's create the example. So let me make the folder basic agent example. So let's make a main.py here. So let's start doing the coding from pydantic AI import base model. So from pydantic import base model, and sorry, this comes from pydantic itself. From pydantic import base model, from pydantic AI import agent. So we'll have to first define our structured response. So let's define our response format. So let's make it a weather response base model. So for weather we'll have to define what we are doing, we are giving the base class and we are inheriting the base model. So what is it? You can do a command click or control click. This is the class that we are going to extend. It has some inherent functionality and we are going to utilize that. This comes from the pydantic. So let's make location str temperature. Let's give it a int. Condition, that would be str, and recommendation, it is also in string. So we expect our LLM to get the response in this format. So now let's make the weather agent same way we did in the previous session. So now what we are going to do, we are going to tell it grok, and let's take a model llama 70 billion versatile, and we want, now this is where you can force your model to give the result type as weather response. So it will force the model to give the response this way. Then you will have to define a system prompt. So you can say you are help full weather assistant always provide temperature TPRA TURE in Fahrenheit. So let's keep the prompt short. Now, so the main thing, model, response, and the prompt. So this will make your agent, it is sufficient for the agent to give the information. Later on in the more advanced tutorial, we are going to hook an API that will give the exact values. So let's try to invoke our agent. So let's do dunder name equals to main, and we are going to get the result is equals to where the agent dot run synchronous, and we can ask what's the weather like in the San Francisco. And we are going to, let's first print the complete response, and then we'll see how we can parse that response. So we can do uv run, it's in the basic agent and main. Okay, so again from .env import load.env. So now let's see, let's again run the above example. So there is an error, did not match the schema. Result is sunny. Let's go temperatures. And there are some error. Status code is 400 from Llama 3.3 versatile. Let's try to run it again. Maybe there's some error. Okay, so from the error, it is expecting this to be an integer, but the model is returning it as a string. So let's try to make it as string. Yeah, so it works. So the problem that we were getting, temperature, it is returning as 65 Fahrenheit string. Now here we did not specify the model to only return the value. This is what we are going to learn about fields in Pydantic, where we can tell our model to use the correct response. I mean, we can have a response level control. And there is another error, which is there is a depreciation warning that we are getting, is the result type is depreciated, use output type. So we can do that so that this warning will go away. Run the basic example and it's working. Again, you can see that it's right now every time we run it gives a different output. So this is very unpredictable, but this is a basic example. Here you should more focus on how can you get the result and how can you parse it. So next what we are going to do, we are going to parse it. As I said, the output is a pydantic model. So let's see if we can parse it. And you can also like do a type validation. It's type to be weather response. So now you see how our IID is going to help us in the result parsing. So let's say location, and now you say result dot look. Now auto completion is coming because we have specified the type. And the temperature, and we can go result dot data, I guess, result dot temperature. Again copy this line. Now next is condition, and then the recommendation. Now let's see, has no attribute location. I think it's there. Okay, so it's a agent. We have to do result dot data. Sorry, result dot output, or you can make it output. A better way would be to remove this error, is to get the output from here, output, and this is weather response. Now I think it will work. Hopefully we'll get rid of all of the errors. Alright, now we were able to parse the result. Why did this happen? Because the agent response is also structured, and our model output comes under the output attribute. From there our base model that we have defined will work. So now this is where pydantic AI really gets really interesting. Notice what just happened. We did not get back new a raw string that we have to parse and hope that is in the right format. We get back a validated pydantic model and properly typed field, and when it was not doing it, it was giving us the correct error that where exactly which field is getting break. So now imagine that the same thing, that the AI is returning an invalid temperature. So now we'll see how pydantic AI will automatically retries to validating the error until it gets the right, and everything in is properly structured and typed. This is the foundation that makes Pydantic AI so powerful for production application. Now we are going to move to where we are going to add the tools and dependencies, and this we can consider as to be intermediate example. So let's make an folder, tool and dependencies, and we'll make a file main.py. Again we are going to re-implement the same weather model but with improved capabilities, such that will give our model ability to execute the tools. And we will also right now will mock the data in this example, and after that we are going to build a production ready in example as well. So let's start building this intermediate example, and this example will show you how to add tools and dependency injection, which is one of the really good feature of Pydantic AI. So let's do one thing. Let's import port HTTPX. We need to hit some API this time. So from data class, import data class. From Pydantic, import base model and fields, because this time we are going to control the out fields. So from Pydantic AI, import agent and run context. From typing, import list. These are going to be helpful. So first let's define the dependencies. So we'll use the data class decorator. So class, let's define a class which is called database connection. We are going to mock the database calling and all. So let's make database connection, and it's better to annotate your class. So we'll see mock database connection, and we'll make it a async def get user preference. I'm just defining a function for our database, and we'll give a fake user ID, and it is going to return our dictionary. In real life this would be a query to database, but right now we are going to hardcode return a value. So let's make our temperature, let's return a user preferred temperature unit. Maybe it is Fahrenheit or Celsius. I'll put a Fahrenheit. HEIT, and then ACTIVIT activity preference. Let's give hiking, photography, restaurants, So let's also make one function that is going to just print the preferences for a user, just so that everything is become handy. So let's define a async def class log user log, let's say log recommendation. Self user id is going to be integer, the recommendation, let's also make it string, and we are going to print it f log user recommendation for the user with user id and their recommendation. So this is just an helper function. Now let's define our response. So let's make a data class weather dependencies. So it requires user id, that is going to be integer, db, which is database connection, and weather API key usually, but for now just let's make it a value. So this is a weather database API. This is just a mock class, and let's now make a response model. So class weather data and the base model, we are going to inherit that. Now let's make first field as temperature. It is going to be a float value. Condition is going to be a string value. Humidity, it's going to be an integer, and wind speed, let's make it a float. Now let's also make a class for personalized weather response. Personalized recommendations, which is going to be list of string, and in the field we can actually define what we want. So here you can see field, and we can give it a description. Recommendation based on user preferences, and so that we can steer down the output. And let's also make a safety alert. LERTS is also a list of string, make it a field, let's give it a description. Let's ask for any weather related. Safety concern. Now we'll make our agent. So let's do weather agent is agent, and then we are going to use grok. This time let's see if we choose a better model. 90 billion, 70 billion, llama 3, Kimi K2. I'm just choosing a better model that has the functional calling capability. Let's start with Queen QWQ 32-bit, and if it supports the tool calling, then that's really better. And let's also, now we can define dependency types. We can give the weather dependencies, and the output types is going to be personalized weather response, and we can make a system prompt. Let me define it. Let's define the system prompt. So you are an advanced weather assistant that provides personalized recommendations, and we can also say use the available tools to get the real world data from the user preferences, provide the specific actionable recommendations based on the weather and users' interest. So far so good. Now what we just have to assign the tool. So let's assign weather agent dot tool. This is the decorator, so it is going to be async def get current weather in the context. We will give the run context, and we are going to define the weather dependency, and also will take a location which is string from the user. So let's also give it the doc string get current weather data for a specific location. Now in real world implementation, this would be an API call. Now we are going to just mock the weather. So now let me define the mock data. weather, it's going to be the first one was the, let's make a San Francisco. Let's define the data. So we have temperature as 68 degree Fahrenheit, condition, let's say partially cloudy, humidity. I am doing it with the same base model that we have defined. Humidity is 65, and when it's time, let me copy it and we'll do it for one more location. This time let's make New York. Let's define temperature to be 84, condition, let's make it sunny, and humidity, let's make it 70, and let's make the wind as 8. So now let's make a way to collect this information. So weather is going to return mock weather dot get location dot local lower, and if for some reason we were not able to get a response, we are going to give a default response as this. So this is a type safe way of doing it, otherwise it can break the code as well. So this way we are going to return the weather information as a string. Weather is in location is location, and we are going to fill the details. Weather is the temperature, degree Fahrenheit, and the rest of things like weather conditions, conditions, and then what do we have? The humidity, and the weather wind. Perfect. So this way, when the agent is going to hit this tool, it will give the ability to retrieve this information. Now we are going to make one more tools, like tool that can hit our database to retrieve the user preferences, and our tool that can log the interactions as well. That will be more handy. So this way we are giving our agent three tools. First is the weather itself, second the user preferences, and third one tool is to log the information for agent. So let's make one more tool, and this time now you will start to see, you will get used to of doing this thing. Let's make async, async def get user and this context, run context, weather dependency, and that's just what we need for now. And now we will see how we can invoke the mock database call. So first thing first, make the docstring, get the users activity and settings. So the preferences, let's make it await, context dependency dot db dot get user preferences. So context dot dependency dot user id, because our context has these information like user id and db. So this way we will get the preferences. Now we can return f user preferences is preferences. So that's how you make your AI agent invoke any database. Now let's make the another tool, weather agent dot tool async def log interaction. So context, run context, and we can give the weather dependency here and also the recommendation, and it will be a string str, and it is going to return a string. So log the recommendation for analytics. So let's make a call, await context dot db dot log recommendation. We can pass the dependency dot user id. See how our IED is giving the correct response, because we have defined everything in the type saved. So we just don't want to show, we just want our AI to show that that it has executed this tool. Now we are going to use this agent. So let's make an async main and let's define our dependencies. Whether dependencies, let's create it, make user ID as 123, db, let's give database connection, and whether API key, let's give it API key. Now result is equals to await whether agent dot run. This time we are not using run async because our function is asynchronous, and we are going to give a prompt as I am planning outdoor activities in the San Francisco. Today, what do you recommend? So this will make our agent to force it to make a weather API call and also the user preference call. So once that is done, it is going to give us the output. So let's do some formatting and let's print the result, and also let's do one thing dot output dot data print temperature result dot data output dot weather dot temperature and condition. So it will be weather dot conditions, and then humidity, and then speed, do we need anything? Yeah, so for personalized recommendation, we'll see first if this is working or not. So if underscore name is equals to name, import async IO. So async IO dot run, it's going to be main. So let's see if it runs. Okay, it's showing an error here. Okay, so uv run to main.py. all right, .env. Okay, okay, so it has been, the model has been decommissioned, so we'll have to use another model. Grok 4. Let's see if we have the access. Okay, sorry, so it has to be Grok Q. Let's see, let's stick with the llama. Llama 70B versatile. Hopefully this time it will work. Yeah, so see here it has given us the output. So this is the output that is coming from the API. Now let's also see if we were able to get the user preference. For result data, sorry, output dot personalized recommendations, because it's an array, so let's see. Recommendations for, let's be were also giving the alert. In result dot output dot personalize dot safe dot output dot safety alerts, and we are going to print slash in a new line Now let's see if it invokes the database. Yeah, so as per the user safety alerts, it is saying be careful, too strong winds, and bring an umbrella. So yeah, that's how it works. Wear a jacket. So let's see if it was in the personalized recommendation. So this is where the Pydantic AI really starts to shine. We learn how to do the dependency injection working seamlessly Our agent can access database connection, API key, user data, whether it needs. Tools are just regular Python function with decorators, making them super easy to test and maintain. And notice how the agent automatically figure out which tools to call in what order to answer the user's question. So this is what we call system 2 level thinking. And the agent outputs provide personal recommendation. And so for an advanced tutorial I am going to link the GitHub repo code, because this session has become quite a long, and we will continue building the more application with in next tutorial with Olama, uh, which is using our local AI model, and then after with the open AIs. So this will be short tutorials. After that we are going to learn the graph of pydantic AI, and that will complete this playlist. So thank you for watching. Please make sure to subscribe. Bye. In next 30 minutes you will master OOPs in Python, from classes and object to inheritance, polymorphism, and a real word design. If you are writing function, your code still feel messy. This tutorial will change the way you think about writing Python. Let's say you are building a fleet manager for delivery truck. So in procedural programming, it starts as simple. So let's build a basic way of writing Python code. So let's say this is code1.py. So for that you are going to define the variables. Let's say truck name is equals to truck1, and truck capacity is 2000 kilograms. Truck location, let's say warehouse A. And then you define a function that will utilize those variables. So drive truck name or let's say destination, and let's simply print right now the truck name is heading to destination. So if let's call this function drive truck name truck, let's say truck, let's send it to truck location, and if we run code1.py, so it says truck1 is heading to warehouse A. It works until it doesn't. Let's say you add another truck, so and you want to track more info, let's say schedule, fuel, maintenance. So your variables become like a spaghetti. So this is where the OOPS steps in, not just to organize but to think like a system architecture. So this is where in Python you will going to learn about classes and objects. So let's start from scratch. And what is class? Think of it, it's like a blueprint for building object. Let's build a truck class. So now let's make a code equals to .py, and in here we are going to define a class. So how to define that? You'll type class and then you say truck. This is the class name, and then you'll have to define the class initialization method, which is in the dunder init. It takes self as an argument and the variable that you want to define. Let's carry on the previous example. Capacity, location. Now we are taking these information from the user of this class, so we'll need to define variables and do the variable assignment. So let's assign self.name dot self.capacity as capacity, self.location as location. Now this is how, when you initialize an object, this will do the assignment work for you. Now let's define a function. Let's call it drive. So self dot destination and we are going to print self dot name is driving from dot location to destination, and then we are going to update. Once the truck reaches there, we'll change their location to the destination. So that's how it works. And now let's do the usage. So let's define if dunder name is equals to main. Now we are going to initialize the truck. So truck1 is truck. Let's give it a name as A, and its capacity is 2000 kilo, and it is in the warehouse. Warehouse A. So, and then this is the initialization step is done, and now we will send this truck drive to destination city center. Let's see if it runs. Code2.py. So see, it is saying a truck name is driving from warehouse A to city center, and these are the internal reference, whereas this is the outside reference. So you see this object has a memory. It knows its state, meaning where it has originated, and this is just the beginning. Now, as this is the basic OOPS class, next thing we are going to learn about the encapsulations, where the protect which is matter to you. Like encapsulation means keeping the internal stuff hidden. You don't want user directly changing the fuel level or say balance in your bank account. You give them access only through methods. So let's build another example. this example we'll name it as encaps, short form for encapsulation. Let's now again create a class. This time let's make a bank account. Now again render init. It takes a self, and let's say an account opens with a balance. So balance. So let's assign self dot balance and balance. So what I did here, just notice the double underscore, it's not a single underscore. So this is a double underscore. You just keep a notice on it and see the usage. So let's say we make a function deposit. So it takes self and then an amount. And then what it does, it is going to increase the balance by that amount. Same thing, let's make a withdraw. Self amount that they are going to withdraw. Now if the amount is greater than your balance, obviously you cannot withdraw that amount. So in that case we'll raise an exception, value error, insufficient funds, and if this is not the case, then we are going to adjust the amount from the balance. And let's make a also function that prints the balance. Get balance, it takes self, return self dot under balance. This is what we have done, the encapsulation, meaning you have only access through this function but not through the outside the class. So let's see any usage, then it will become more clear. Name equals to let's define the account, and let's bank account. Let's open an account with $1,000 balance. So let's do one thing. Let me try to retrieve the balance directly. Let's see what happens. Hopefully you'll see an error. See, it says it has no attribute balance, but you can see it is present. So what it does, it has kept it hidden from direct usage. Instead of that, if you use the encapsulation, you will see you have the access. See, 1000. Now let's make some withdrawal. Let's say 50, and then again print a balance, and then account deposit, let's make 1000, and then again print the balance. So it should become 950, then it become 1950. Let's see, this is what initial balance. We remove 50, then we added 1000. So that's how it works. Now next thing we'll need to learn about the inheritance and polymorphism. This is used when your code evolves. You know what's better than writing code? It's reusing it. So inheritance lets you extend the functionality instead of copy pasting. So let's inherit our bank account class. Let's make another class using your bank account class. So class, let's make saving account. This is a special type of account that inherit the bank account. It just has new functionality, which is apply interest self and interest. Let's calculate it. Self dot get balance, whatever be the balance, let's add 3%, 0.03. This is the interest. So self dot, let's make a deposit of that interest. Sorry, I think I have made a typo. Yeah. So this is the saving account which has another functionality, and see, I am using a function from the parent class. It's not present over there visually, if you can see, but actually it is present. So this is the power of inheritance. Now if I'll come here and if I'll make it as saving account, everything remains same. Now what I'll do, account dot apply interest, and after that let's print dot get balance. So let's see if we are getting interest. Yes, so after the amount we are getting the interest. Now you can also see the polymorphism in action. So let's make two different types of account now. See, a account, let's make an array of bank account, normal bank account, initialize with 10,000, saving account, initialize with 1500. Let's say for account in accounts, let's in both account, let's do a deposit. And if is instance account, if it is a special saving account, look, I'm checking here. So we will apply the interest, and once all of these things are done, let's comment out the code for now. We'll just print dot get balance, and let's see if it applies the interest. Yeah, so for normal it just added, and for the savings account it added, but it also gave us 3% interest. So see, with just one same calling we achieved two different things. Now they are, if you look, their calling is same, but the outcome is very different. This is polymorphism. So now that you have understood the basics of OOPS, the abstraction, encapsulation, polymorphism, let's build a real world OOPS program. Let's build a ride hailing app core logic. So let's get real. Suppose you are building a basic ride hailing system. We'll design class for driver, vehicle and rider. So let's make the code car.py, and let's first define the class of driver. Def under init, and driver takes name. What else? Driver takes license number. And let's also first define the structure for other class. Let's say vehicle, and let's define init, and a vehicle has their make and plate. And let's also define class ride. So def under init, let's say a ride needs to have driver and it takes a vehicle. So now you are seeing, if you get the sense, we might be giving this ride class two classes. So let's first implement the assignment is name dot license number as license number. Same thing here. Self.plate is plate. Now let's see. So self dot is driver. Same way self dot vehicle is vehicle. Now we can define a function which says start self, and it prints, let's use f string, self dot driver dot name is starting your ride in a self dot vehicle dot make, and we can give the vehicle plate self dot vehicle dot plate. So now notice how these objects are composed. So this is called object composition, a powerful design a powerful design trick in OOPS. So if you see the usage, let's define takes name as, let's say, A, and plate name is 101, and let's make, after that we have vehicle, and vehicle takes make as, let's say, exp, and just an example, and plate as 014, and then now we can make the rider class, initialize the rider class. So rider ride will take driver comma ph, and then rdr dot drive, it's start. So now we should be using the variables from the composite one. So see, A is starting your ride, this is the make, this is the plate. This is a composite example. Now you'll need to learn one more concept, which is called abstraction. This is what this does. It hides it is essentially hiding the complexity with clean interference. So you don't need to tell engine how to, let's say, rotate. You just say start. That's abstraction and exposing only what's necessary. So let's make a class code, or maybe we can do it here as well. So let's make class engine. So let's say def start self print for now. Let's only print. Now let's define the class car. So let's say def init, and it takes self dot engine is equals to engine, and now let's define drive. Self dot engine dot start, self dot engine dot start, and print. So car is moving. So let me show an example. Let's say car underscore is carr, say car dot drive. Let's see what we get. So it says engine starting and car is moving. So this is what is called the abstraction. We took the abstraction of engine class in the car class. So the user only sees, if you are writing this car function, user only sees car dot drive. Okay, car underscore dot drive, but under the hood engine is kicking in, and this is what makes it clean and elegant way of doing it. So one more thing is, like, while writing the oops code, try to avoid those mistakes. So one is the God object. Do not try to cram everything into one class. Too much inheritance. Prefer composition over inheritance. And yeah, make sure that you are using the best practices. So what my final thought is, we just build a truck, bank, ride system and a car, all using OOPS. But now it's your turn. So try building a library system: book, member, library, add, borrowing, return, due date logic. Make it feel real. If this made object oriented programming finally click to you, drop a like, share this with your Python buddies, and subscribe for the next one. We are just getting started, and OOPS is not just how you write the code, it's how you design the world. Thank you. So here you can see we were able to make the query, and it's returning as 4 document. D6. We are going to learn about how to use LangChain with the latest model GPT-5. We are going to run this tutorial on GPT-5, but if you want to follow with free and open source model, you can try the Grok, which is exactly same. You just, in the base URL, you'll have to specify the Grok API's base URL. Rest of the things will be completely same. So let's start with the absolute basics of LangChain. We'll first learn how can we load a model and invoke it. So let's create a folder. Let's make it chapter 1, or let's make it module 1, and let's make a file basics. So now first thing first, we'll need to do the installation. So let's go to LangChain OpenAI, and let's copy this command because we want this. So let's install it with the help of UV. So if you don't know UV, there is a video in the channel, like how can you use UV. We will be using the UV extensively. So now let's start our hello world of the LangChain. So from LangChain OpenAI, let's import Azure. I will be using Azure Chat OpenAI because I have deployed my own GPT instance, which I will be using. For that tutorial will also come how can you also deploy your own GPT private instance. So let's go and this is the model that we do, and in the model we'll specify GPT-5 mini. This is how you create a model client. Now let's see how we can invoke this. So let's call model.invoke, and let's ask this something. What is the LangChain? CHAIN. And let's also print response.content, because this is what we want. Now let's run this code. Module 1 basics. Okay, so this the basic error. It was not able to discover my credential. So for that we'll need to load the environment variable from .env import load.env and then invoke this. So this should fix that error, and hopefully we'll get the response from my Azure. Perfect. We were able to connect to our model, and the model has also responded. LangChain is a developer framework building applications. Key concepts: why use LangChain, example, JavaScript example. So perfect, this is what we wanted, and this is the basic. Like, you'll have to make sure that you are calling the model. This is the invocation. Now let's learn how to make this. Is not the way I have given the message, it works, but let's see how LangChains want us to give the input. So this is a human message. So now let's import from LangChain core dot messages, import human message. Now all we have to do, we'll need to prepare our message. Let's define prompt, and it will be an array list of human message. For now we'll just pass human message. What is the let's ask same question. And what we will do, we'll remove this line from here, and we'll pass, this time we'll pass the prompt, and rest of the things are same. So we'll run the code and see. Perfect, it worked as previously, as same way. And this is how the human message, like this is our human message. Same way there are AI messages, and then there are other message type as well. So now let's look at the system message. So again, from LangChain core messages, let's import system messages. So once you do that, we can define a system message as message. So let's define system message. Here we can right now define any message, like any system message. Like if you want to make a chatbot for any particular a use case, so for that domain you can make it as an expert or a peer, something like that. So that you can do here, for example, we can write you are an expert on radiology that respond to the user query with correct information. So this is going to be the behavior of the model itself. Now what I'll tell you, let's separate our human message from prompt. So let's make it human message, and then we are going to, in sequence, we are going to pass these information to our model. So now we'll prepare a list, or maybe I can do it here. message list. So first we'll pass the system message, and then human message, and then we'll invoke our message list. So this should pretty much give us an idea. And let's ask this, what is X-ray scan? Let's see if it answers our question. Alright, so we have our answer. An X-ray is a medical image test that use small amount of ionized radiation to create a picture of the inside of the body. It relies on the fact that has different tissue absorb X-ray to a different degree. Yeah, so this is great. This is the in context generation that we wanted from our model. Now that you have learned the structure of human message system message, now we will learn about the prompt template. So we'll cover that in the next video. Thank you. Prompt models in LangChain. We'll learn about the prompt templates and how can we invoke them with our models. Also, we will learn about the variables that we can place inside our prompt templates. So for that, let's create a new file. We'll name it prompt py, and let's copy the code from previous session. In most of the lecture, we will be needing this much code always. But what it is doing, it is importing the LangChain Azure AI chat OpenAI. If you are using the OpenAI directly from Azure, then there is called chat OpenAI that you can directly use. For my case, I have the Azure subscription, so I will be using the same one. Now we'll learn about the prompt and models. So let's prepare a prompt template. So in previous video, if you remember, we have imported the human message system message from code. For now, we don't need them because we will be learning the prompt template. So let's import the LangChain code prompts and import prompt template. Now let's prepare a template. Prompt template, prompt template. Now for here, you can define a docstring or a string. So let's define a use case, and let me write a system prompt and a context question same. So this is the idea, like there will be a system prompt and there will be a context that we can replace when we are invoking the model, and after that we'll set the question. So let's answer the question based on the context only. So let's enforce the condition that the model should not go outside the context. If the question cannot be answered using the information answer with, I don't know. Now let's give context, and this is how you define what you want to place here. So I want context to be placed here, and then after that the question. And we can say type your answer here. So after that model will generate the answer. So this is what we have done. We have prepared our template. Now prepare the prompt. Is equals to template dot. Now we are invoking. So see, we are invoking our template first, and the template we have to define it as a dictionary right now, because we want to pass the context. We have defined two variables and then the question. So let's give the context. Let's say the current Prime Minister of India is Modi, and we'll pass this as a context. Now let's prepare a question. So who was the Prime of India in 2010? Let's give the information of which year it is. 5. It should, although the model knows it from their training data, but we want it to enforce that I don't know, because it is outside the context. So let's see, it would be very interesting to see if it follows our uh, the the context that we have provided. And let's print the response.content. So UV run module prompt template. So it says I don't know. Now if I'll ask this question as in 2025, let's see, Modi. So now you see the model is responding as per our context. This is what makes it very important uh, to control the model behavior. So yeah, so this is how you do the prompt template. Now let's learn about the chat prompt templates. So this is prompt templates. Now let's import from langchain core.prompts. Let's import chat prompt template, and let's comment out these. Now let's prepare our template again. This time it will be a chat prompt template, and from messages I'll start with the basic one. Then we can also put the human message or AI message here as well, but let me also give you the basic way of doing it with the help of normal Python objects. So inside our lift, let's define a tuple, and this tuple will contain the system. This is going to be a system message, and we'll we'll copy paste same thing. Let's keep the system message separate, and then here what we are doing, we are breaking up the uh, way of conversation. So this goes first. After that, we'll take the human, and human will give the context. So after that, human will again give the context. This time, the question. Question. And we'll now let's copy this code. Let's copy the whole, because the invocation will be same. We'll just uncomment this. This is context question, and now we can pass this into the model. This model dot invoke prompt. See if it should still work. Yeah, same thing. The ways are different. Previously, we were defining all of this in a string. Now it has been broken apart in terms of uh, the system prompt, then human message, then again human message, and so that's how you prepare the prompt template. And in our next chapter, we are going to learn about how can you retrieve a structured response from a model with uh, so that we can ensure the model output will always follow a particular structure that we want. Thank you. Can we get the structured response from our LLMs? So let's copy few codes from the previous lesson. All it is doing, it is importing Azure Chat OpenAI and loading the environment variables. And we will be using GPT-5 Mini. So how can you make sure that you will get a structured response? So for that, you'll need to install a dependency which is called Pydantic. So once Pydantic is installed, let's go and import the base model. And we will define a schema based on what we actually want from our model. So let's define so this is how it is done. You create a class that will inherit the base model. So let's define the location info and base model. So we'll make a chatbot that that once we give the location, it will tell us about the uh, weather and place to visit. Let's see. So this is going to take it will take the information and give location. This will be str, and then we'll use docstring and we'll get the location, the user from the users query, and will also it would be better to define docstring. It will be passed information. Now let's define justification. Justification give the why you think user is asking about location. And let's now, since we have our LLM ready, so usually for structured response, we want the temperature to be 0. And to get the structured response, we'll have to make our model as structured LLM. Let's make it LLM. It is model dot with structured output, and we want the location info. This is going to be the schema, and let's collect the response. Structured LLM invoke, and I live in Delhi. I want to visit Mumbai. Help me plan the journey. So let's also make a plan. This is going to be list of STRs. So define the plan for the user. And let's print the response. So let's run UV module 1 structured. Yeah, perfect. So we have the information as location, Delhi to Mumbai. Justification, user is asking for help planning from Delhi to Mumbai. I'll give you a clear transport option. Here is the plan, step 1. So because it is a pydantic schema, so we can enforce and we will get back some help from our ID, hopefully. So let's parse this output. Let's print this. I'm just doing some formatting. Let's run this again. So if it model is not able to parse the output, then we will, now you can see we were able to pass this information. See Mumbai traveling from Delhi, asked to visit Delhi plans, and here is the plan. Perfect. This is what we wanted. There is another output parser apart from the Pydantic. Uh, there is a common CSV output parser, and let me just show you like how it works. I'll comment out this code. It is useful sometimes. So let's import from langchain core dot output parser, import comma separated output parser. So let's prepare our parser and comma separated output parser. So let's prepare a simple list as the CSV parser. Let's see value 1 comma 2 value 3, and then print the response. So what I'm trying to tell you that, I mean, there are multiple other parsers as also available that you can check out from the implementation. There is another JSON output parser, simple JSON output parser, list output parser. We had just explored one of the ways, and like you can control click on the module. It's command click for Mac, control click for Windows, and then you can all look like what are the things available. I just showed you one of an example, uh, like with Pydantic and the CSV parser. Most of the time you won't be needing it if you are using the for I mean structured output in as a JSON. We usually want it, so you can use Pydantic models to get a structured output, and it really helps in creating chains, more complex chain that we are going to learn about in the upcoming session. In the upcoming session, we'll learn about chains. So thank you. In chains, we will learn about various way of writing chain, the imperative method as well, and the LangChain expression language method as well. So before that, I wanted to give one concept of methods, like how can you make a invoke of a model as a batch or as a stream. So this is an important thing that we missed in the basics lecture. So let's first learn that, and then the concept of chain will become very clear. So from LangChain OpenAI, import Azure. If you are using Grok, you can import the respective client. So let's make an LLM. So also I need .env, right? Load. Let's load our .envs. This will load all environment. Let's make our LLM client Azure Chat OpenAI, and we will use GPT-5 mini. 5 mini, and let's call the first one, you know it, using LLM dot dot invoke. By now you know how to use it. Now if you want to make a multiple invocation as a batch, this is what you have to use. So completions is equals to model LLM dot batch, and here you need to pass the list. So let me ask what is chain, and next in batch I'll ask what is Python, and let's print this out and let's see what we get. Module 1 methods. You should see answers for both of them. Alright, so if you see the response here, there is one AI message and then there should be another one for the next question. There you go. This is the another AI message that we get back, and the content is LangChain is open source, Python is a high level general purpose language. If you see, there are other things as well that we get, like reasoning token, rejected token, prompt detailed tokens. We are going to learn more about them in the upcoming lecture. Since GPT-5 is a reasoning model, so it takes some of the reasoning and then it gives back the output. So this is perfect. Now, if you see, whenever we are calling our model, we are getting response back completely when we complete when the completion is done. So what if I want to get the output as it gets generated? So for that, there is called from tokens in LLM dot stream. Sorry, it is 4 stream, and then your question would be, hi, how are you? And then you can, it is an iterable, so you can print the token as we collect them. So this time we should see the response as we get. So if you see the content, I am just a virtual assistant, so I don't have feeling. And you'll see the other things like run ID and finish token. Reason stock model is this. So these are the information that we get. If you just want the content, then you can also just see the model output as well. Just put dot content. Now with this done, we will learn about the chains. So let's bring this much code, which is bringing the LLM and then bring the LLM. And this time we are going to use the previous concepts of from LangChain. Let's import from LangChain core dot messages, import human message, and then system message, AI message, and we'll also bring the chat prompt template from LangChain core dot prompts, import chat prompt template, and let's learn the imperative way of creating chains first, and then we are going to also learn the length chain expression language way, which is more convenient. But learning imperative way is also useful because then you'll have more control over your chains. So first of all, we have defined our LLM. Let's also define the template. Is the chat prompt template dot from messages, and let's put the system message. Let's say you are an full assistant, and then we'll put human message, which is going to be question, and let's make it a variable. We'll pass that value from while asking the question. So now what we want to combine them in a function with at the rate. There is a decorator from LangChain core runnable. Let's import it. Runnable chain. So let's define our chain chatbot. What we will do, we are going to combine this prompt template with the model. So let's prepare a prompt. So right now it is a template. Now once we add the question, it will become the prompt. It is going to be template dot invoke with the value, and let's return LLM dot invoke and the prompt. So now let's see the response from the chatbot. Chatbot dot invoke, and here we'll pass the question. What is the biggest our solar system? Let's ask this question. Let's print this dot content. UV run module chain oh, human message. All right, we okay. So we cannot pass it as this is using this way. So what we can do, we have also learned the other way. So it is a human and then question, then it will work. Yeah, so it picks the question. Jupiter is the largest planet in the solar system, and what I was trying to do, we'll learn in the upcoming session how to like use messages to inject the the parameterable values. So for now, this is how it will replace question here when we do invoke. Previously, I used directly the human message, which is not the correct way of doing it. This is the correct way. Sorry for that. And now, once you understand the imperative way, you then you can also understand how to. This is a uh, invocation. Now, how can we stream this invoke? So we have just learned that in the previous just 5 minutes ago, like to stream the token because we got the output once everything is done. So let's stream the output from here. Once our prompt is ready, we can do for token in LLM dot stream. Then you can pass your prompt, and from there you will yield it. So since you cannot return it, you will yield it. And so same way when you are calling the model, so let's how you can see the response. For parts in chatbot.stream. So look, the because we have added this decorator, we are getting like these methods already implemented for us. Let's take it same question, and this time we should see print part and yeah. So as it was streaming, let's only put the content. Then it will be more clear. That's how you stream the response. See, it's coming, and that's how you must have seen in the chat. Uh, chat models like OpenAI. There you see the tokens are getting streamed. So that's how it is done. And so this is the way. How now we'll learn how we can do it asynchronously. So this is a synchronous way. So now for that, what we have to do, we have to await it, and instead of yielding it, uh, we are going to make a asynchronous invocation. So let me comment that part, and let's await it. And it is a invoke, which means it is an asynchronous invocation, and this function has to be async. Perfect. Now we can await until the output is coming. It is LLM dot a invoke, and then your prompt. So let's define an async main function, and return await chatbot dot a asynchronous invocation, and let's ask this same question. Now let's call if name equals to Let's import async IO and we will make a asynchronous run dot run. See, this is how you make an asynchronous calling, and you just make sure to await it when you are making an asynchronous calling. Now let's learn the declarative way of doing the same thing that we have been doing, like chaining the prompt and the model. So let me comment it out. So this one is the handy one. Let's combine with the OR operator, this pipe operator. So see, we are making chat, same chat bot is what? First of all, it takes the template, then it passes it to next is the LLM, and this is the most easiest way of doing that. So once you do that, you can reuse the same code that we have printed here, and it should work without an error. Let me see if everything is right. Yep. See, you are getting the same answer. This 90% of the time we will be doing this thing, but there are some requirement where before the invocation of the model and prompt, we want to manipulate the input from our own end logically. In those cases, we will prefer to use the imperative one. And we have learned, since we have learned all of the ways like asynchronous, synchronous way, a streaming way of making chains. So that clears up all of your basic fundamentals of how can you use the LangChain effectively. So from this completes the module 1. Next module we are going to learn the various data fetching loading techniques, and thank you for watching this session. Bye. About the retrieval augmentation generation, short form RAG. So this we will going to learn about end to end of it. So the first step of making any RAG system is to load the document itself. It could be from anywhere, and we are going to see various methods how we can load our data. So I have taken a PDF, a text file, and a markdown file, and let's try to read them and see using the LangChain how can we do the loading of a file. So for that you'll need to add the LangChain community. So once this package is installed, so let's from LangChain community dot document loader, let's import. Let's first load the text loader. This is the class we have imported, loader dot text loader, and then you need to specify the path. So I have this text file. Let's get the relative path of it, and we have to specify the encoding is the UTF-8. and then that's how you loader dot docs dot load, and let's print the document. Now let's run it. Module 2 rack loader. There you can see we have loaded a document. So good thing about this, it creates the metadata of the document itself. See, metadata, source, the file of path, and then the page content will be very convenient for us when we are making the rag, like when we are inserting the document. So this structure will become very important. So now let's try to get our document from a URL. So for that, make sure that you have beautiful soup dependency installed. Let me do it. Let's also do bs4. So it will install beautiful soup 4, and now we can import web-based loader, and let's comment them out. So same thing, loader, web-based loader. Here you need to specify the URL. So let's get the document of, I'm just making an example. You can make any URL, you can pass any URL here. Make sure that if they do not detect us as a bot, then you will be able to get the document. Load. Let's print what we have loaded. Perfect. See, now the metadata source, we are getting the title and its language, and this is the page content. See, we are getting multiple informations. Now, once you learn about the loader, then one of more important is the PDF loaders. So let's also learn them. So there is a class which is PyPDF loader, and same thing again, the PyPDF loader, and we'll need to specify path to a PDF file. Let's copy the path, and rest of the things are exactly same. Okay, so we need to install PyPDF, no problem. Perfect. So what we get, document, producer, creator, creation date, title, author, metadata, modification date, source, total pages, page 0 content. In a very structured way, we have read that LangChain paper that we want, because these informations will be very handy when you are creating any RAG system. So now we just have loaded our document. We cannot put an entire document to an embedding model. So for that we need to learn about the text splitting. So in next lecture we are going to learn how we can split the loaded text. Thank you. We have learned about how can we load the document as a text for our model with their metadata and all. Now let's learn about how can we split those text recursively. So for that we are going to import one class from LangChain text splitter, import recursive text splitter, and from LangChain community dot document import text loader. Let's use the text example. So again, it is going to be text loader. Then you pass the path. I have a file here. Let's use it. And let's define the encoding is UTF-8 loader dot. And then now let's create our splitter. So it is recursive text splitter. We need to define the chunks of split that we are going to do. So it is chunk size let's give thousands, and then chunk we how much overlap we want between the chunks. It is 200. You can define as per your requirement. So let's make our docs. It is going to be splitter dot split documents, and then splitted docs, and let's print the splitted documents. This is the basic way of doing the splitting. See, this document has been splitted as one because the text was very small. So let's make it and smaller chunks. This was really big chunks. Now it has been splitted up in the smaller chunk, as you can see. Will be what we can do. Let's for let's print this 50 times. Then we will print the doc. See our splitted text. Now these are the chunks. Now let's see how can you, because we know this is in generic text, there can be chances where you have to import based on certain languages you want to make split. So there is a language class. Now let's create a because this document does not create any code. So let's do one thing. Let's prepare a Python code. So it is def hello. I'm just preparing one simple documentation that prints the hello world, and let's also add comments. Simple function. Now when we are doing the splitting, this time we are going to call from language, and here we need to specify which language. So language is language dot, this is Python, and let's make the chunk very small. Let's make overlapping 0. So let's see now how the splitting will be done. One second, because we have loaded again the text one. So when we are calling the splitter, we need to pass the code as a list. Python code. Let's see. Okay, so recursive character text splitter. This is the correct class. The language. From languages. So we should not call the split document. In this case, we'll call create document. Then we will be able to get our code as the documents with the chunk size of 10 characters. Here you can see. So we were actually calling the wrong method earlier. So that's why there's the error. So once this is done, let's also learn how can, because most of the documents we will be storing them as a markdown. So let's also learn the markdown way, just as simple the Python code. Let's make a markdown. I have a markdown example. Let's copy it, and we have pasted it, and let's markdown, and here we have to change it to markdown. Let's increase the chunks. Let's make them 100, and this time we are calling the correct create documents class, and this is the markdown text. Let's because we are creating the document, I'll also tell you how you can uh, specify the source. So let's because I have taken this from the langchain.com, so let me put the source as this. Should see we have created our document from markdown text. So these are the documents and the metadata source it has also taken it. So this will be very useful if you are loading your own data and you wanted to make sure to specify the page number and all in the source. You can do that. And this is how you do the splitting. In the next lecture we are going to learn about the embedding. How can you create embedding from these loaded text? Thank you. About the embeddings now, we have learned ways how to load the document and how to split them. Now let's learn how can we convert those chunks into embedding, because models only process embeddings only. So to do that, you need to uh, have a model that can take your input text and convert them into embeddings, the vector representation. So let me show you how you can do that. So from LangChain OpenAI, import OpenAI embeddings. I will be using the Azure. Normally, you can use OpenAI's, but since I'm using my Azure model, so I'm using Azure OpenAI. So for that, I have to .env import node.env, and so that it loads all the credential. And let's create our model client, Azure Open Embedding. The model name, model that we are going to use is this text embedding ADA 002. So we need to specify the model name, and then let's create the embedding. Embed documents. So you can pass your document. We can write any text. It could be loaded from anywhere. So thanks for watching. Yeah, so these, let's say these are our document chunks, and now once we pass them to embed the document, then we can print the embeddings that was getting generated. So this is how you make the embedding from the documents. Yeah, sorry for that. Yeah, here you can see we got the vector representation of the text that we have written, and let's see the length of the embedding that got generated. Let's take one of the document. So it is 1536, the length of this embedding. So once this is just a toy example. Now we are going to take a better example where we are going to load this document. Let's load this text file and then create embedding from there. So what we can do, we can copy some part of the code uh, from our previous code. Let's bring them here. So LangChain text splitter, load document, LangChain doc, and then we will call. Let's first bring this up here. So now what we can do, let's recursively split this document. Recursive character splitter. Chunk size is, let's keep 200. I think 200 would be enough. Then we can do chunk overlap. Let's make it 20 characters. Let them overlap, and then let's collect the chunks from our splitter that we have created just now. Dot split document, and here we can pass the docs. Now on our embedding document, what we can do, we can pass the chunks instead of these example chunk chun chunks dot page content for chunk. Actually, because it's an array, so we'll have to iterate it. For chunks in chunk, we'll only pass the page dot content. And once this is done, let's actually print all of the embeddings. Let's print the length, how many embedding it has created, and let's print one of the embedding just to see everything works fine. Perfect. So it has created 41 chunks. For all of them, it has created this embedding, and that's how we are inching very close to creating rack. And in the next lecture, we are going to finally create a vector database using Postgres. We'll host the vector database locally with the help of Docker. Then whatever we have learned till now, that is loading document, creating chunks, creating embedding, we are going to index those documents into the vector database. Then we'll use them for our LLM to make an informed decision. So thank you for following this session. Thank you. Now we are going to learn how can we make an actual rack system, defining the name as PG vector container, and I'm setting some of the environment variables like a default Postgres user and the default Postgres password as well. Let's make it password, and after that let's also set an environment for Postgres DB. Let's mark it as LC for now. This is going to be the database name. And now let's define the port mapping from 6042 to 55432. Now we can define the PG vector as the Postgres 16. Once this is done, it has created a container. We just need to start it. So once this much step is done, let's bring LangChain community and import text loader. So from LangChain OpenAI, let's import Azure Chat OpenAI and also the Azure AI embedding. For now, let's only focus on how we can make production ready embeddings. So in the LangChain text splitter, let's import recursive text character splitter. And from LangChain, let's also bring Postgres for vector store, and let's import pgvector. So from LangChain community, let's first import documents, and then let's bring a UUID because we are going to give a unique ID. So now let's define our connection URI, which is going to be Postgres, and we will be pointing to our localhost server that we just now created. So you have to define like Postgres SQL plus PS copy and the database and the password. I have made it password, connected to the localhost, the port that we have defined 6024, as you can see, and then go to the LC collection. So now let's do one thing. Let's load the raw document from text loader that we have learned about in the second episode of this series, and let's bring this document. Let me copy the relative path, and that's how it's done. So now we also need to specify just in case encoding, and once this is done, the text, we need to call the text splitter that is going to recursively create the chunks of this document. Let's define the chunk size of 1000, and let's also define a chunk overlap. Let's make it 200, and then what we are going to do is these document, let's load them text splitter dot split document, and from the raw documents now we are also need to bring the embedding model. Let's use ADA 002. Let's refer this model. So let's use same model. Let's also not forget to import load.env, so such that our credentials are being fetched properly. Now we need to define the pgvector from documents. So we need to define document and the embedding model. Let's also pass the connection URI. Let me handle it. So now we have the Postgres connection class is available. Then we can do this similarity search. Let's define a query. Just let's run it and see if everything's working fine. Let me ask a question. What is LangChain? So now let's do uv run module 2 db, and let's see if our server is running. We can also check the logs as well. We can see it's running, and let's see, it will take some time because it's going to chunking. And so actually there is a problem with connection string. I have fixed that. Now let's see this, right? We have one more error. Let's add this dependency. Hopefully after that all errors will be gone. I am going to add those error parts in the video so that if you also face same errors, then you can just come to this section. So one thing to note, you'll need ps copy 2 to be installed as a dependency additional to your LangChain. And so here you can see we were able to make the query, and it's returning as 4 document. So perfect. Now we were able to make the embedding and the connection. Now we need to learn how to add documents. Let's say during the runtime, let's say when the chat is happening, if you wanted to add some embedding. So for that you need a unique UUID. So let's create UUID 4 would be better. And once that is done, so we are creating 2 UUIDs just for test. Let's also add 2 documents corresponding to that, and let's add some page content. Let me write some quickly. This tutorial is written for LangChain, and let's also define a metadata. That's very important, because it's the same way we have done recursively with the help of the pg vector.format document. So let's maintain the consistency here as well, and let's copy paste it again. And there you can see. Now let's modify it a little bit, and let's write LangChain is awesome for making the AI development. All right, now let's move on to the next part. We need to define a ID. So let's provide the ID array that we have defined in line number 34. And let's do some formatting, and let's see if this is successfully done or not. So let's also do one thing. As soon as we add them, let's also delete them with the help of those UUID, because that will be present in the session. So we can call db.delete IDs, then we can pass the ID array that we have defined. So this will ensure that the fundamentals you need to learn, like CRUD operations, are important. We were able to do retrieve, but creation and deletion is also that much important. As an AI engineer, you should be well aware of that. So now let me add some debug this time. So hopefully everything works fine. It's going to do embedding again, and then it is going to add some document and then delete document. We should be able to see the logs when it happens. So yeah, document added, document deleted, perfect. That's all we wanted. And yeah, so this is what you need to understand. All right, everyone, let's learn how can we do the embedding management with the help of LangChain in our Postgres database. For that, let's import indexes, which is SQL record manager and index, and we'll also import our vector store from pgvector. After that, let's also import the LangChain OpenAI. From there, we'll import the OpenAI embedding, and let's also import LangChain doc store documents, import documents. So what we are going to do is, let's copy the connection string that we have created. In the previous lesson, we have created the vector database. So this is the connection URI. And now what we are going to do is to initialize a class with the help of this connection URI. So in pgvector, we need to pass the embedding model. So let's also collect it from the previous code. Let's pass it here. So let's pass embedding model as embedding model that we have initialized above. After that, we need to also give the collection name. So let's create a collection name. Let's initialize a constant collection, and let's call it YouTube Talks. Now, once we are done, now let's also create a namespace that will be helpful. Let me give it a name as YT namespace. Let's save it and then pass it. And we can also pass the connection URI, and we need to make it use JSONB as true. So by doing that, our vector store is initialized. Now we need to create a record manager. So from SQL record manager, let's give it a namespace. So namespace that we have defined. Let's give collection the DB URI as connection URI. And this is what we need Now let's create the schema. This is going to initialize all of the required structure into our namespaces. From documentation, let's bring same documents that we did in the previous class. Let's add some documents. This is going to be the content. Now let's modify the metadata as IDs. Let's pass the IDs for now manually, and we can now define, let's say, a source, which could be, let's say, a db.py file where we are trying to retrieve this information. So let's do same thing here, and now let's also copy this and let's give it some name. Usually when you are creating an embedding, there's already a tutorial present where you can learn how to do embedding from documents, multiple file types. So now let's initialize the index. Let's pass our vector store, and we'll do a incremental cleanup. Now let's pass the source ID key as source. With that, we will be able to index those documentations. Now let me add a print statement to see if this is done correctly. Let's call our function. So uv run module 2 rack embedding management py. Here you can see we have added attempt 1, added 2 documents, and we were able to do a update. Now let's try to do second time, and this time you'll see what is the use of doing an incremental. So now if we run it, you'll see it got skipped because we have same document already present there. This is very much important if you want to keep your racks a clean one, because you don't want duplication to be there. So that's where the record manager will help. Now let's see if you intentionally want to modify some record, that is, you want to do a mutation. Let's change the page content of our document 1. Let me type this is a new content that added in the doc 1, and let's try to do the mutation this time. And let's also copy paste the print statement, and this time let me comment out the previous code. So you see here what just happened. Now since we have changed the content, now it only skipped one, which was the one that was exactly same, and it deleted the index 2 and added a new in replacement of that. So this is important thing to learn, and in the next tutorial we are going to sum up everything that we have learned and build an actual rack system. Thank you very much. All right everyone, finally we are going to conclude this series as we are going to build a rack system. So we have been able to learn a lot of things, specifically in focus to create a rack system with the help of LangChain, and now we are going to bring all of the things back here, because we are going to bring the Azure Chat OpenAI model, the embedding, the databases that we have created, the text splitting using an actual document. So for all of these things I am going to do an import quickly for you, and as you can see, let's import LangChain core. Let's import prompts, import, let's import chat template, chat message prompt template, and we'll also need some other things from LangChain, that is the runnables. So we need chains, because I'm going to show you how can you make a chain execution of rack, which is very an interesting way of calling your rack system that makes your code really clean when you're building things in production systems. So here what I've done, I have bring all of the embedding model text splitting documents the way we were doing in the episode 1. Feel free to check it out. And from there, what we are going to do, we are going to create databases, and we'll need to pass our embedding models. After that, what we are going to do is to bring the collection. So the connection URI we have provided in line number 11. Let's call our retriever. So we'll call database as retriever, and then we are going to set the quarks. Let me search the documentation. It's written there. Yeah, this is the search quarks, and there we can specify the k value, that is the number of similar document that we are going to retrieve. And then let's call query what is LangChain, and what will happen, this retriever is going to invoke this query. Let's call it, and then we can see the documentations. So this is not how you are going to do an actual. The proper way of doing is through calling a chain decorator. But for now, let's see if everything's works fine. And so let's create a chat prompt template, and there we are going to give this retrieve doc as the context. Let me write a simple prompt for our model. So answer this question only with the following context, and we are going to pass the context, the question. Now let's invoke our LLM. Let's use GPT-5 mini. And we'll set the temperature to 0. So LLM chain, first LLM, prompt, then LLM, and let's see, this is going to be our LLM chain, and we can call dot invoke, and then here we can pass a dictionary of context in the question. So for context, let's pass the doc that we have retrieved from our retriever, and our question. So let's pass the query. Now let's see what has been returned. So this is how usually it goes. First retrieve document, pass it in the context, and then ask your LLM to generate response. Let's run it. It will take some time because it is creating an embedding, saving them into database. For the first time it will take some time. Meanwhile, make sure to check the other videos where we have learned all of the concepts that we have developed so far. So here you can see we got the context, and this is what we have saved in the documentation. That's why it is returning from there. This is awesome. Now we are going to learn a better way of doing this thing, which is, let's use the chain decorator. let's at the chain, let's define its QA agent, and we'll pass our input query, and here we are going to call the retriever as invoke, and we'll pass the input, and then we'll format our prompt dot format prompt dot invoke, and then pass the same dictionary. So the context as the docs, we need to pass this in the dictionary, and then also the question, which is our input. Now let's format it, let's invoke it. Let me call the LLM dot invoke, and then we can pass the formatted one. Let me see if everything is fine here. Let's actually, we need to call the LLM chain because it has the prompt and LLM. Let's see, let's just run it and see if everything's work fine. Let's call our let's collect the response of QA invoke, and let's pass the query. Let's see the context directly. Let's run module to rack, basic rack, and hopefully there is no error. I feel there's something missing here, but that's not an issue. Let me re-verify it. Clear LangChain, and I think we should call the LangChain because no, actually we have to call an LLM, as the formatting we are calling on line number 56. Sorry if I'm creating confusion, but I think that's the way. Yeah, let's see. Yeah, it throws an error. So yeah, it's happening because we need to call the LLM here. Then everything, it was correct on the first time itself. Let's run it and see if it works. It's taking some time. That's okay. Meanwhile, let's sum up things that we have learned. This series was basically in focus of learning the rack concepts that usually you won't find on any YouTube tutorial, because people do skip those concepts. They are indeed very much required. And then now we are going to move on to LangChain graphs or LangGraph, and we are going to deep dive into agents and all. So there you go, we have our output, which is pretty awesome. This is what we wanted. Thank you, really thank you very much for watching this series. I hope you enjoyed it. Thanks. Hi everyone, we are going to do the fine tuning of GPT OSS. Let's first connect our T4 runtime. You need to ensure that you are running a GPU instance. To make sure, click on the runtime, change runtime type, and make sure that you select T4 GPU. Once that is done, we have to install some of the dependency that is required for fine tuning this model. So let's install with the help of UV. Let's install Torch, PyTorch, Unsloth, and Transformer. Now this is going to take minutes depending upon the latency of the server. Now what we need to ensure you have matched the versions of the proper versions, Tritron versions. Otherwise it will create problem in Colab only. But if you are running it on any GPU server, depending upon the CUDA version install, you'll have to tweak the required library as well. So just to make sure. And we are also going to track the system RAM GPU disk usage on the for this model while it is training. Let's see how much time it will take. So since this is done, now we are going to load our model. So let's see how it is done. So from unsloth we are getting a an object which is going to load our model. We'll also import torch, and we'll keep the max sequence length of 1024 for now. And d type you can define, but it will automatically pick the d type if you set it to none. So it is bringing the GPT OSS 20 billion parameter model and the sequence length that we have defined, and we cannot fine tune the whole model in this GPU, but what we can do, we can load the quantized version that fits on T4 machine. So for that you'll need to enable that flag, and we will not be doing any full fine tuning because we will be using LoRa fine tuning. And if it was a gated model, then we would have to pass the Hugging Face token. For this case it is not, so we'll just comment out that part. As you can see, the model shards are getting downloaded. It's a bigger model, so you'll see multiple shards that will be getting downloaded. Now you can see the model has been downloaded, and see our GPU RAM consumption. It has taken 11 gigs of RAM out of 15. So the model is loaded in our GPU memory. Now we have from fast language model, we will get the PEFT configuration. We'll be using the LoRa rank 8. Depending upon your use case, you can increase it. The higher the rank, the better quality of the fine tuning will be. For this short tutorial, I am going to use only rank of 8. And next, what we are going to define which sets of weight of LoRa we are going to do fine tuning. So here you can see we are fine tuning the KQV and down and up projection matrices. This is the scaling factor, and we are going to run this. So this is the configuration. You can use your own configuration as well depending upon your requirement. And from now we are going to load an Hugging Face dataset, which is multilingual thinking, and we are going to split the train set, and we are going to also from unsloth chat template we will bring the GPT template, and this is how we standardize the dataset. And then we have to format the prompt. So for any examples from this dataset, we'll bring the messages where the conversations are there, and in the tokenizer we'll apply the templates and then put everything in the text, because for Hugging Face dataset this is how we need, so that the mapping will be done. Once this is done, let's print one of the records. So if you see the chat, the complete one example for training, it start with the start token, then the system, then the message of system, your ChatGPT model trained on OpenAI, knowledge cutoff, current date, reasoning medium, and then this is some instruction. And then once it is done, you'll have to end token, then start message, and then the user message. I have only shown the 500 first tokens, so that's how it is. You just need to make sure that this structure is done for each text in your dataset. Now after that, from TRL we are going to import the SFT trainer and SFT config. So in SFT trainer we will have to pass our model where we have attached the LoRa head and the tokenizer dataset, and the configuration is the GPU configuration and how many steps we are going to run. Ideally it should be in multiple epochs, but for this tutorial I am going to run it for few steps. Actually, let's run it for 10 step only. And learning rate and optimization, if you are sending your weights to some like weights and batch services, then you also need to specify it here, and the output directory where you want to save your model. Now this is some configuration to get the GPU stats. You can see here as well, but we will also print how much RAM usage it has done. So once everything is set up properly, we just have to call the simple trainer.train. It will trigger the training, and we'll see the 10 epoch might take 5 minutes, and it also depends on the data set as well. So I'll fast forward the training. As you can see, the 2 epochs warm-up epochs has been done, and our GPU consumption is also getting increased. So let's see how after 10 epochs we are going to load the model, and we are going to ask it a question to think, and in French language solve this equation, and let's see will it be able to do that. So as you can see, 10 epochs has been done, and our training loss has also decreased. It will decrease more if you train it for more epochs. Now let's see if we are able to get any output from the model. What we have done, we have loaded our question to tokenizer as an input, and then we are passing model to generate. So you can see now the model is generating the explanation for this, and it is doing the chain of thought, if you can see. And once everything is done, you can model.save, and it will save the model as the fine-tuned model. Here you can see, and in the output you will also see the model intermediate safe tensors, the checkpoints, and LoRa adapter configurations. So this is how you can fine-tune the GPT OSS model. Thank you for watching this tutorial. Thank you. Okay, imagine a sports car but shrunk down to a size of skateboard, and it still beats the full size sedan in a drag race. That's basically Google just pulled off with a new Llama 3 270 million parameter model. the 270 million parameter model in AI terms, that's tiny, but here's the ticker. This little model can run powerful instruction follow AI on your phone without draining your battery. See, in AI, bigger is not always better. You just need to hang a picture. You don't bring a wrecking ball. Gemma 3 270 million parameter model is exactly that, a perfect size, purpose built model. It's not here to replace massive LLMs like Gemini Ultra. It's here to make AI fast, cheap, ridiculous, effective, and for a specific job. Under the hood, you got 170 million embedding parameter, because this thing knows 256k token vocabulary, which means it handles rare world and niche language like champ. Add 100 million transformer parameter and you have got a muscles of reasoning and instruct following. And efficiency on Pixel 9 Pro, as per the Google, the integer 4 quantization model handles about 25 full conversation and only used 0.75% of the battery. So, and you have got the muscles of like reasoning here in your phone. That's not just good, that's unheard of. Out of the box, Gemma 270 million follow instructions like it's been trained, because it has, but the real magic happens when you fine tune it. Think sentiment analysis, entity extraction, routing queries, and even creating writing done offline, privately and fast. So like why it matters? Companies like Adaptive ML already prove that smaller specialized model can outperform massive general purpose one when fine tuned right. They beat larger proprietary model on multilingual context moderation. So Gemma 3 270 million takes the playbook and make it even more accessible. So you want to try it? I'll share how you can use your own data set and fine tune Gemma this model. So there is a link in the description which will take you to this collab. This is a free service from Google where you can use their GPU. So first thing first, because we are running it on the collab, you have to do the installation. We will be taking help of Unsloth. So it is going to do the installation of TRL PEFT. These are the required library that we need. So now once this is done, we will be pulling our base model from Unsloth, and the instruct tune 270 tiny fast strong for task. This is fine tuning in maximum length. You can take any length, but I am taking 248 as the max length sequence of word. So we are loading this in 4-bit full precision, or T4 it can be trained fully, but for this tutorial I am going to stick with smaller precision. Now with LoRa parameter efficient, instead of updating all of the weights, we are going to only update the downward and up projection matrix with the rank of 128. Once this is done, so like there are other parameters also, like target modules, the attention, KQV, O projection, plus MLP gate up down, where this is where LoRa helps the most. And we are using LoRa alpha as 120. It scales the LoRa update. It is paired with the rank. And Unsloth optimize for 0 dropout can hurt, PEFT at small scale. Bias is none, and this is going to be the like off here. You see the RS LoRa can stabilize very high rank. So LoRa Q is for low rank continuant noise, and we can explore it more later. Now we will be moving to data preparation. This is the format where we have to format our data set. That is beginning of whenever you are providing one example, you have to add the BOS tag, which is beginning of sequence, and start of turn. Same for start of turn for model and user. You just have to provide which is the start of turn. So user prompt, model output. Same way you have to wrap around your data set. Now from Unslot chat template, we will be using the Gemma 3 chat template, and we are going to load our data set, the alpaca data set, and let's load a very small fraction of it, and then we will map this data, because this data has 3 column: instruction, input and output. So this is the way we are going to form our conversation. Once this is done, we'll do the dataset mapping. It's done. Now we'll also need to do the formatting of the dataset, as everything comes under a text field. If you will visualize, you see 400 record text. This is the complete formatted text. Now this is where your SFT trainer is present. So what is happening, like this dataset field text, it is telling the TRL where the prepared string lives, and we are going to use the batch size of 8 and max step. For quick demo I am taking 30 only. For complete fine tuning you should consider using higher steps, or even go for epochs. And this is how it is done. Now let's prepare our trainer. It is going to load the data in our VRAM, and there is one optimization from Unsloth they have provided. We'll also going to use it. Let's see if the masking is done properly. You can see now, since now everything looks good, so now we can start the trainer with trainer.train, and it will start training the model. Once that is done, we are going to take one of the sample and do an inference. So you see this is happening quickly, and loss is actually getting decreased because it's a very good capable model. Already we are using a base model that is bit capable, and this training is done. You can train it for more steps and you'll see better results. Now you can see the model, we are making inference, and it is generating the output for our question. And let's see, yeah, this is done. So you can, this way you can save the model and you can use it on your embedding. They are the secret sauce behind every smart AI apps you have ever used. From Google search to ChatGPT memory to the recommendation for you feeds that somehow knows exactly what you want. But here's the catch: most embedding models are either too big to run locally or too generic to work for your data. That's where Google's brand new embedding Gemma changes the game. At just 308 million parameters, this tiny beast can run offline on your laptop or even on your phone, while still beating model twice its size on the industry gold standard benchmarks. And in this video, I am going to show you something Google does not teach you in the docs: how to fine tune embedding Gemma on your own dataset. So imagine this: you have got thousands of customer support chats, research paper, or even your personal notes, instead of relying on generic embedding, we'll train Gemma to understand specific domain language, so your AI app can answer question more accurately, recommend better context, or even become private offline search engine for your file. So stick around, because end of the tutorial you'll not only know how to fine-tune Gemma, but also how to evaluate your embedding, so you don't just guess that it's working, you actually prove it. Alright, let's dive in. Now let's start the training of this model. So we are going to train this on our custom dataset. For that, we'll need to ensure that we are running on the GPU server. So make sure T4 is selected and then install the dependency that it requires. So this dependency will take about 1 or 2 minutes. Once this is done, you'll need to make sure that the versions is correct as I have written in the URL. So let's clear this out and let's log into Hugging Faces. You'll need to provide the token. And once this is done, we can download the model from Google, embedding 300 million parameter model. So this will ensure that the model is downloaded, but you need to do a sign up or agreement acceptance that you need to do from your side. So that will be done in Hugging Face. Once this is done, we'll need to prepare our dataset as a triplet. So from dataset, let's import load dataset, and we'll create a custom function which is triplet. It is going to take 2 sentences and 1 negative sentence. From this dataset, we'll get 2 sentences and their similarity distance. So since we know that similar sentence will have less distance, so let's prepare a third sentence from there randomly where the similarity is high. So now we'll create a condition and take a negative sentence. From there we can create a triplet. Anchor and positive is going to be the same, but we'll have a far distance embedding as the negative sentence. So once this is done, from dataset we are going to load this and prepare the dev test and train triplet. So let's print this out and see how the dataset preparation is being done. As here you can see, the dataset for training has about 1000 examples, and for dev and test it has 100, 200 and 200. It is having anchor positive and negative. And see one of the examples of the training set, like a plane is taking off. The positive one is airplane is taking off, and the negative is a young wearing a hat. So that makes sense. Now we need to define the task name, which is STS. So this task name will be passed to the model, which encodes this query into an embedding, and also for the documents that we are preparing. So once doing that, you'll need to do the similarity between the query and your documents. This similarity will tell how two are related. So here you see I have written one food example where breakfast should have a higher embedding, lower embedding distance compared to rest of these two. So let's run it. As you can see, this is doing pretty well from the base model itself. So let's say, for example, if you want to now fine tune it on your own dataset, then you'll have to use the sentence transformers trainer, and from there you'll need to pass its a configurable argument, and the loss function is multiple negative ranking loss that you'll need to pass your model that prepares your loss. And these are the arguments. We have to take the prompt with the STS task. For this I'm going to run it for 1 epoch, and learning rate is very small, and we are not going to report this to weights and bias, otherwise you can put there, then you'll have to log in your weights and bias. Now this is a custom callback which at the end of the training it is going to do the evaluation, call the evaluation function, and will evaluation function is just the same query. The document that we have run above, here you can see this is going to run it while during the evaluation. So once this is done, we can start the training and pass the model, arguments, dataset, loss function, and what is going to be the callback. So let's run it and see how it is working. I have already ran it. For now I'm going to run it, and you can see your GPU consumption will start to increase from there. So let's give it a minute. It's going to take about 1 minute from here. So after the training, it is going to save the model, and then you can use it for doing the inference on your server, or you wanted to host this locally for your use case. But this model is very useful for mobile devices and where applications where the latency matters, and resource constrained devices is going to be very useful. So once this training is done, you can use this model. And thank you for following this session. Thank you very much. Embedding. They are the secret sauce behind every smart AI apps you have ever used. From Google search to ChatGPT memory to the recommendation for you feeds that somehow knows exactly what you want. But here's the catch. Most embedding models are either too big to run locally or too generic to work for your data. That's where Google's brand new embedding Gemma changes the game. At just 308 million parameters, this tiny beast can run offline on your laptop or even on your phone, while still beating model twice its size on the industry gold standard benchmarks. And in this video, I am going to show you something Google does not teach you in the docs, how to fine-tune embedding Gemma on your own dataset. So imagine this, you have got thousands of customer support chats, research paper, or even your personal notes. Instead of relying on generic embedding, we'll train Gemma to understand specific domain language, so your AI app can answer question more accurately, recommend better context, or even become private offline search engine for your file. So stick around, because end of the tutorial you'll not only know how to fine-tune Gemma, but also how to evaluate your embedding, so you don't just guess that it's working, you actually prove it. Alright, let's dive in. Now let's start the training of this model. So we are going to train this on our custom dataset. For that, we'll need to ensure that we are running on the GPU server. So make sure T4 is selected, and then install the dependency that it requires. So this dependency will take about 1 or 2 minutes. Once this is done, you'll need to make sure that the versions is correct as I have written in the URL. So let's clear this out and let's log into Hugging Faces. You'll need to provide the token. And once this is done, we can download the model from Google, embedding 300 million parameter model. So this will ensure that the model is downloaded, but you need to do a sign up or agreement acceptance that you need to do from your side. So that will be done in Hugging Face. Once this is done, we'll need to prepare our dataset as a triplet. So from dataset, let's import load dataset, and we'll create a custom function which is triplet. It is going to take 2 sentences and 1 negative sentence. From this dataset, we'll get 2 sentences and their similarity distance. So since we know that similar sentence will have less distance, so let's prepare a third sentence from there randomly where the similarity is high. So now we'll create a condition and take our negative sentence. From there we can create a triplet. Anchor and positive is going to be the same, but we'll have a far distance embedding as the negative sentence. So once this is done, from dataset we are going to load this and prepare the dev, test and train triplet. So let's print this out and see how the dataset preparation is being done. As here you can see, the dataset for training has about 1000 examples, and for dev and test it says 100, 200 and 200. It is having anchor positive and negative. And see one of the examples of the training set, like a plane is taking off. The positive one is a airplane is taking off, and the negative is a young wearing a hat. So that makes sense. Now we need to define the task name, which is STS. So this task name will be passed to the model, which encodes this query into an embedding, and also for the documents that we are preparing. So once doing that, you'll need to do the similarity between the query and your documents. This similarity will tell how two are related. So here you see I have written one food example where breakfast should have a higher embedding, lower embedding distance compared to rest of these two. So let's run it. As you can see, this is doing pretty well from the base model itself. So let's say, for example, if you want to now fine tune it on your own dataset, then you'll have to use the sentence transformers trainer, and from there you'll need to pass its a configurable argument, and the loss function is multiple negative ranking loss that you'll need to pass your model that prepares your loss. And these are the arguments. We have to take the prompt with the STS task. For this I'm going to run it for 1 epoch, and learning rate is very small, and we are not going to report this to weights and bias, otherwise you can put there, then you'll have to log in your weights and bias. Now this is a custom callback which at the end of the training it is going to do the evaluation, call the evaluation function, and will evaluation function is just the same query, the document that we have run above. Here you can see this is going to run it while during the evaluation. So once this is done, we can start the training and pass the model, arguments, dataset, loss function, and what is going to be the callback. So let's run it and see how it is working. I have already ran it. For now I'm going to run it, and you can see your GPU consumption will start to increase from there. So let's give it a minute. It's going to take about 1 minute from here. So after the training it is going to save the model, and then you can use it for doing the inference on your server, or you wanted to host this locally for your use case. But this model is very useful for mobile devices and where applications where the latency matters, and resource constrained devices is going to be very useful. So once this training is done, you can use this model. And thank you for following this session. Thank you very much. Hi everyone, today we are going to learn about how can we create our own Azure AI Foundry through Azure portal, and you are going to learn how can you deploy your own private instance of GPT-5 model or any open source available model. So look at my deployments. I have done GPT-4o mini and GPT-5 mini for my personal use. So once you do the deployment, you get a target URI and an API key through which you can point to from your code, you can point to your private instance of the model. And you will also see model catalog where you can get other versions of model. You can click over them and see which model that you want, like what pricing does this fits under your pricing, what is the output cost. So all of them you can get this information from model checkout. And there are also other models, open source models are available. So let's look at one of the Microsoft's 5.4 reasoning. You'll see this model, you can pretty much do a deployment and then you can pay as per the this is the serverless cost. So deployment does not cost anything. Instead, the cost of usage is the one that you will be paying for. So from after that, then once you do, they have also provided the playground where you can play with your deploy model. You can set a system prompt and then you can see how it's working. Here you can see it has replied because GPT-5 mini I have deployed. So let's see how can you go. Click over the create button and then head over through this search bar and then type Azure AI Foundry. So you'll see that in a list. So once you get there, you will see the card of Azure AI Foundry. Let's click on create and this will give you a configuration form where you'll have to select your resource group. So once you have selected the resource group, you can provide any name convention that you would like. Prefer the hyphen between the words. I have written it Azure AI Demo YouTube. Choose a resource region where you want this deployment to happen. If you deploy it very far away from your usage, there will be data charges might apply, and then you'll have to create one project where your artifacts, containers and all will be stored. Now the network settings, this is where you configure any network security. Like if you wanted to your firewall to only allow certain IP ranges, then you can do that. For example, I am just putting one random IP, so this IP range will be allowed. And same you can try with other one as well. Let's put 30 here. And or you can also disable no network access. So this will be completely private endpoint. So you just need for your internal network through your VPN, you can actually configure the private endpoint. So just select the cognitive services because that is the one we are going to create, and then your firewall network that you have created, and then subnet, and then your DNS zone. So once you do that, you will be able to set your OpenAI that works only internally through your network. And after that, you'll have to set the identity, how you want your system to give privilege to other users. So in my account, I am the only user, so I will be going with system. But for organization, so you can assign the user based identity. From here you can allocate your user, and then accordingly you can make them project manager or contributor. So now they are asking if we want to encrypt our data. So if it is required for you to do the encryption, then you'll have to also set the key. And once this is done, now you can give a tag like what environment it is it for prod stage, so that becomes handy when you have multiple projects. And this is how you set the tags. Now let's create this as a demo, and then moving on to next. Now we just review once several settings that you wanted is achieved. Here you will see if you have configured network access, you will see the subnet and IP ranges. We have allowed all networks for now. And now let's click on the deployment. So it is initiating our deployment now. Then after that, it will take us to the deployment screen, where you'll see the status of the deployment. And here you can see it is deploying two things, the one cognitive services and then the your Azure AI Foundry. So let's wait for it to be done, and you can collect the all configuration from here. If you wanted to do it from Terraform, then this is also, as a template, is also available to you, so that you don't have to do it manually again and again. And you can see also the operation details. Let's click and see all of the unique ID that is getting generated. You'll find it here. So let's wait for it to be done, and then we'll open our newly created Azure AI Foundry. There we are going to do the model deployment. It is going to take about 1 or 2 minutes, depending upon the region. Sometime it might also take more than 10 minutes as well. So the possibility is there. So if there's any error, then they'll try, you can try to try to recreate it. Now let's move on to the portal it is created for us. You'll see your API key, you can copy from here, and then you'll also see your endpoints to access different Azure AI services, including text to speech, speech to text, and then there is also your Azure AI services. You can create your agent as well. You can assign the protection. You can create guardrail as well. So first of all, let's go to the objective of this video. Let's deploy the model. Let's deploy GPT-5 mini. I'll show you the steps, but I'll not do the deployment. I'll leave at the button where it says deployed. Rest of the thing I'll do. Let's click on GPT-5 mini, confirm, and then you can type select the deployments type. I'm selecting global standard, and then you have to, if you wanted to do some customization, like if you want your model to remain at certain version, you can also maintain from here. You can also opt out of it. You can see if any resource group where you wanted to do this deployment, and you can limit the rate limiting from here. It will be set, and once you do that, your deployment will be shown like we have shown in the starting of the video. And once you do that, you'll see your model can be used from anywhere, because we have allowed any IP range. For now, what I will do, I'm going to delete this resources, because I already have one of my resource where I am right now using it. So this is important because next we are going to start the LangChain series, and I will be using the OpenAI services from Azure only. So stay tuned for that. And if you wanted to do a complete follow-up, you can follow these steps and do your deployment and get ready for next exciting video that are coming up. We will be building production grade agents system. Thank you. This app looks complex, right? Behind the scene, it's just a graph, not a visual one, a code first graph. What if I told you you can build an agent workflow like this in pure Python? Type safe, debuggable, and resumable without writing a single if-else loop. In this video, we are going to build a real-world AI workflow using pydantic graphs from scratch. Just clean, scalable logic that actually ships to prod. Here's what we are going to build. We are going to build a agentic e-commerce management system that is going to take the user orders, do a DB lookup and validate. This is we are going to build in the Pydantic graph as part 1, and after that we are going to build a system for fraud detection in the same node. So you will learn how to turn your basic graphs into a state machine that can take actions. So if you are tired of patching LLM workflow with duct tape, stick around. This one will change how you ship your AI apps. Let's build this step by step. See what we are going to build today. We are building an e-commerce system in 2 phases. So the starting stage is requirement gathering, and then after that we will have a validation node. From validation we are going to inventory check. So from there we'll go to payment processing, and from there we are going to go to the shipping calculation, and once we are doing, we will confirm the order. So that is how the main flow will work. If everything is fine, if anything fails, we are going to end this graph, or in some cases we will reroute to the starting edge. So you'll see a simple graph that is present over here. This is going to be the phase 1, meaning we'll not be introducing any agent. We'll just learn the basics of graphs and the edges, end node, the base nodes. Once we are done with that, then we are going to introduce the agent as fraud detection or suspicious behavior. So this is where the true value is of any agentic framework. Is like we will be doing most of the things with business logic truly in terms of graphs, but things where we need the AI agents, we are going to introduce them. So for example, we are going to have an AI agent over here. In the inventory check we are going to add, in the process we are going to add an AI agent that checks for the fraud detection. Shipping optimization, we will introduce an agent here, and then finally a report generating agent that is going to conclude their finding. So in this way we are building in 2 phases, and we'll make sure that we have learned all concepts of Pydantic AI agents and Pydantic AI graphs. So see you to the coding session. Let's start the implementation. We will create a file for this. So let's create the file as ecom let's name it as ecom graphs. So the idea is, first we'll learn how to build a graph, and then we are going to in further tutorial session we are going to learn how you can bring the Pydantic agents into a Pydantic graph. So understanding of graph is really important. this example. In the next example is going to teach us how to use graph for a production level grade agentic workflows. So let's import few important things. To work with graph, we need annotations. So let's import it from future. And we also need data class. It will be coming from data class. And we also need field. From typing, let's also import annotated. Yeah. And from pydantic graph, okay, so we'll need to install the pydantic graphs. So let's see, PyPy. Let's go there, and this is pydantic -graph. So we need to do uv add pydantic graphs. It is going to install all of the dependencies. Now we can import modules from pydantic graph. Import base node and end node, and we also need graph class, graph run context, and an edge. Yeah, so this is the building blocks of a graph. Let's also import async IO, and we are going to import random also. Let's see if we need it. Now let's first define the structure of an order state. In pydantic graph, state is everything. So state is something that your agent node are going to transfer to each other. So let's try to give as much as information. So let's write a docstring state for the order processing workflow. Let's think, what are the things we need? We first need an order ID. That's typically string, could be none as well. So we'll make sure to handle all edge cases as well. And customer ID, this will be string or none. Let's also assign initial value as none. And then there could be items that a person is trying to purchase. So that could be list of str. So maybe we'll make it more complex. So let's make it list of dictionaries. And initially let's assign it as a none. And let's say total amount empty. Total amount would be a floating value, and let's assign this as also none. And then also payment method is also I'm just adding things that I could use. Payment method, that would be str or none. Let's assign this as also none. Shipping address, that would be a dictionary. Let's, because there are multiple things in an address. And let's see, let's also add inventory available. So let's make it bool. And also assign this as none. Now we'll also make some flags like payment process, PAI. So this would be bool or none. Let's assign as none. And is there any flag? Let's also add shipping cost. That would be float or none. Let's assign this as none. If you just try to write along with me, status, let's make it str, or let's make it by default pending state, because all order will be in pending state. Processing steps, so that would be list of str. We'll try to record these steps that are being taken by this graph. So let's give it a default factory as a list. Let's also keep track of any errors that we might occur. List of, that would be str, and let's field default factory of list. So this is our base order state, and now this is the state that we are going to pass on to the multiple nodes of graph. Let's define our first node. From here we'll do the node definition. Yeah, so let's do the first step as validate order. So this is going to be a identic graph node. Validate, you have to define your class, and it is going to inherit the base node, and that base node takes the state as order state. So that's how we make the validate order as a node. And let's put a docstring here. Validates the incoming order, and let's do one thing. Let's assign some variables. Order ID, let's make it str, and customer, that's also str, and items, list of dictionaries, and then payment method, let's make it str, and then shipping, address, let's make it dictionary. So these are the things that we are going to take whenever we are going to place any order. So now let's define the ACE, SY and C. def run, this is what is going to run our node. So this is self context, and we are going to pass a graph run context, and it is taking in order state, and we also need to annotate what is it we are going to return. So we'll use annotated. So let's check it. It is going to, the next step of this graph is whenever you validate an order, you are going to define a inventory. So we'll add a node later. Let me write it here. Let's make a check inventory that we will define, and it can also end here because the order might be invalid. So order or there can be some error that can also occur. I mean, in this case, okay, so it should not be an end. It should be an edge, because this is a valid order when check inventory. The other case is when the it goes to an end node as an str, and it will take an edge, and the edge will have label as order. So that should be fine as long as our graph is completed. So let me check once. From this graph everything's fine. We take the check inventory, and if something wrong happens, then we take end and edge. Seems perfect to me. Let's start doing the implementation. So we'll do first a check if context dot state is empty. Then in that case we'll have to assign a empty state. I mean, if they pass for some reason state is just an edge case. Now in that case we'll be update the state. So context dot state dot, let's assign the order ID as self dot order ID. Same way, context dot state dot customer ID is going to be self dot customer ID. Context dot state dot items is going to be self dot items. And what else we need? Yeah, payment method. Context dot state dot payment method is going to be self dot payment method. Context dot state dot shipping address, self.shipping address. This is what information we are going to take from user. So now let's do an arbitrary calculation, like let's calculate the total amount. So this is what usually you will do. You take control from agent and perform your business logic. So let's do, we need to multiply price with quantity. So let's go for item in self dot, I think it's item for items, and once we get an item, then we are item will add price multiply by item, and it's going to be quantity. So we'll add this field in the items. So what this is going to do, this is going to calculate the total sum, a shorthand way of doing that. And what else can we do? So once we do this thing, we need to update the context as well. State dot, let's update the total amount because we just calculated it. So that way we ensure that our states are kept updated. So let's do one more thing. Dot state processing steps. Let's append that we have like validated the order. So order self dot order ID is validated, and let's also maybe we can do more checks. So let's bring this more down and let's perform more checks. Validation error. Let's say if not self dot items. So because in prod, I think we also need to bring these down. So let's do validation first, then we will do the calculation and all. So if we don't have any item, then we are going to add an error message. So in context dot state dot error, we are going to append, since we made it as a list. So we will add the error message. Order must have a paste one item, and let's add more thing. So once this is done, we can actually safely calculate the total amount. So once the total amount is also calculated, we are going to do one more validation. Let's say total should, if it is less than or equals to, which is an invalid. So we are also going to append in the context dot state dot error dot append, we'll add the error messages, order 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 total must be greater than 0. This is very important, because you don't want your agent to give you don't want your agent to let the user get items for free, so you need to think of those scenarios as well. So also I'm thinking we should also add the something related validation for shipping address. Let's add a type safe way of doing it. Like, we need to have the street name. So in that case, state dot errors dot append, let's add valid shipping is, so that our LLM or agent, they know that the user has not put the valid street or the valid address. So in those cases, we not only let's also make sure that we don't proceed to next state. So in graph it's important. So let's do one thing, because we are not able so let's return from here. We'll go to end node from here because validation failed. So order validation failed, and let's copy it bunch of time. So let's also return from here to directly to end node, and also from here to the end node. And when these things are done, in those cases we will update, then we are going to update the processing steps that order validation is successful, and then we can return to check inventory. What was the name? Check inventory, and we are going to pass the order ID. Let's do one thing. Let's first define it so that we'll not get this quickly error. And let's define data class. And it is going to be check inventory, and now you know that it is a base node that takes our order state, and yeah, so now we know that we can pass the order ID, score ID, self dot order ID, and we can also pass the items, self dot items. So in the next state, this is what we are going to pass. Rest of the things of that order state will be none, because that's all we need. Are those items available, or they are they can't be processed? So now let's implement check inventory system. So in check inventory we are also going to have order IDs as str and items as list of dictionaries. So let's define async def run. Yeah, so async reference context, it will take graph run context and will pass our order state, and what it is going to return, annotate it. Let's see, from here we want to go, let's predefine it, iterate data class will go to payment. Once we have the inventory, I think we should go to process payment. Let's name it process payments, and it is going to take our order state. Let's pass for now. Yeah, so it is going, the annotated class will take the process payment and it will have the edge. Label it as inventory available label. So this is the path when the inventory is available. If it is not available, then from here we are going to end state and will take an str and it will take an edge, label as out of stock. So I mean, this is the possible paths that from this node can happen. Like if we can fulfill the order, or we can't do that. So first thing first, let's validate if the context dot state is none. In this case, we'll make the state as order state, empty state. This is important. Doing that will help us to make sure that the code will not break, and anyways it will take the edge of out of inventory if the context was not provided correctly. So let's access our context dot state dot, let's say, in processing steps I feel like I should append right away that we are into inventory. Inventory check for the order, self dot order ID. So let's simulate a scenario of an API call. This could be your internal API, async IO, sleep. Let's give it 1 second. It will just simulate an API call. Now we'll need to check each item availability. So let's keep a track of unavailable item. So let's iterate this time. Self dot items. What will happen if item dot, let's say, product ID. Let's hard code it. Let's say, let's make a product which is not available, and we'll make, I'm thinking we can make it as random, like let's assign 30% chance of happening this, so that it will be fun to run this. I mean, this is what an actual scenario, like let's do random dot random, and if it is less than 0.3, so usually it returns a number between a floating number between 0 and 1. So if this case happens, like this is the specific, we'll do it for this product only, then we are going to unavailable item dot append, and then item name. This is what we'll do. We'll make sure that item has an ID and name. So now once this for loop is executed, we'll check if unavailable item array is not empty. So in this case, we can add our context dot state dot error dot append, let's say items out of stock, and we can, let's make it f string, and we'll build the string by comma dot join, because it is going to be a list, so they will be comma separated values. It will be easier for an LLM to read this. And once we have we have also made one flag, if you remember, state dot inventory available, let's mark it as false, and then return to an end, because we cannot process it. Inventory check field. So if this is not the case, then we can update our context.state inventory available to true, and the context.state.processing step dot processing dot append. We can now append a message that all items are available. And we can also do one thing. We can calculate the total amount here as well, because we have access to the item state. So let's copy it from here. So we'll pass this information to next state. Just this is going to be process payment. It will be helpful there. So we'll pass order ID as self dot order ID, and then amount to total, and we can make payment method as credit card, let's say. For now, let's hard code it. I mean, this would be scenario where we can enforce that we'll only process the payment with credit cards only. So now let's implement the payment processing. Again, we'll add the order ID as str and amount as float, and we are also taking the payment method as str. It won't be none. Async run async def run self comma we are going to take context graph run context. It is an order state, and while we are returning it, it will be an annotated correct state and the end state annotated. And now you must be, this would be a repeated steps for now. Let's h, give it a label, payment failed, and you know here it is going to be h of label first let's do one thing. It is going, we will define the next state. Let's define data class, and for next step let's do calculate shipping cost, because we are also taking the information. Calculate shipping, it is a base node and it takes order state, and let's calculate shipping cost and delivery time. Let's do it. Let's pass it so that we can complete our function here. So let's make it calculate shipping and an edge with label payment success. So again, let's put a context dot state is none. In that case, we are going to set state is outer state, but if that does not uh, happens, then we are just going to empty state, and that will take the edge of payment failed by default. So now for payment failure scenario, let's make two payment. One is the invalid card state, because we are only accepting the credit cards, and one, let's make a 10% chance of payment failure any amount greater than 1000. That's $1,000. So let's make these two scenarios, and we'll update the street. Sorry, we are going to update the we'll just update the clock calls according to that. So let's simulate if self dot payment method is so these must be this value can come from an API. So in that case, context dot state dot error dot append, we are going to append an error message as payment failed, transaction declined, PAY, transaction declined, and then context will remember we have made a flag as payment status, I guess, payment processed. Yeah, let's make it false because of this scenario, and then we can return an end node as message with payment failed, invalid card. Let's make one more scenario. If self dot amount is greater than 1000, and let's make it random. Random is let's make it this code can execute. This chance of this code execution would be less than 10%, and in that case, we'll context dot state dot error dot append. We'll say payment amount. We can copy it. I think rest of the things are also same. So yeah, in both of the cases, we'll go to end node. So if this is not happening, then we will update the context state process payment process as true. Ideally, it will be an API call to Stripe. You can place your existing logics here. Context is just we are making aware of our LLM that what is happening here. Let's also update the processing step dot append, and we'll tell our LLM that payment of, let's add $, self dot amount, and we'll only need 2 decimal places, two floating point values, process successfully, and we will have to make our default shipping address because there can be a chance that this code will break. Ideally in let's do later, because in the next node we'll have to pass on the address, so usually this will be provided by user, but let me hard code it here. Shipping, and its name street, strwt street, let's name it 123 main street, city, let's make it New York, and zip, code, let's make it 100. I guess this is the zip code for New York, and let's make state as NY, and country as USA. So because these things are required when we will be doing the calculate shipping, there we are going to just pass the order ID as self.order ID, and then we are going to pass shipping, and let's pass the default shipping address. This is now, these are the two things that we will be taking. This is the first step now. Order ID is str. This is what you expect. Shipping address is also str. So now you must be, once you will do practice along with me, then these concepts will become very solid. Then it takes context, and our context is graph run context, and it takes the order state, and it returns annotated, two things annotated. There will be two paths here, and let me see, at this stage we had already processed the payment, so let's do only, because this is the terminal state, and from here it is only the calculation part only. Let's do this only. We'll go to end node. Pre to end node is the confirm order state, so let's first implement that. So it is data class confirm order, and it takes an order state. let's pass it so that we can use it here. So it takes the confirm order having an H with label, and in the label we can specify the like shipping calculated. So why this is required? Because this is for this context is for the internal processes, like because we will be handling, I mean, most of the e-commerce handle payment through their steps. So now, let's all do a quick check. If context dot state on, then we are going to assign it a context dot state is equals to order state. So that case is sorted out. That means we have the context state. Now let's update our processing step. That processing that we are at the shipping calculation for the order. Let's pass self dot order ID here. So let's make an API call, which is just the simulation. We'll call async.io.sleep. Let's give it 1 second. So this will be an external API, maybe Google Maps or something. Let's add a base shipping cost. So these things you want to handle by your own. You don't want any LLM to hallucinate on this step. So that's where you have to take. So this is why Pydantic is all about giving control to LLM, then taking it back. And how well you do it is what makes your agentic code as production ready. If country is international, so we are going to increase the shipping cost, and type in shipping. Let's do shipping. Yes, let's make it base cost, base shipping into 25. Let's make it 25 times costlier. No, that would be too much. Let's add, base cost is $10. We'll add a $25. This could be any business logic. Okay, I'm just throwing the number. If let's make one more condition, if self dot shipping address dot get state, and let's make some special cases, like if this is in Alaska or Hawaii, then also let's make some special provision for, will also increase the cost of there, but not as compared to the international one. And in else case, we are going to make the shipping cost is equals to base cost. And now we can update the context state dot shipping cost is equals to shipping cost, and we can update our context dot state dot processing steps dot append. We can say that shipping cost calculated, and we can pass the information how much the cost was. Shipping cost, let's do it to and since this is done, then we are going to return confirm order ID self dot order ID, and we will need the shipping cost, and we are going to provide the shipping cost. So now let's do the final step of the confirm order. This is where user will see the information that order status. We'll just make, we have one flag which take care of the order status, which was in the pending. We'll make it confirm if the node passes here. So let's do the implementation. We are going to take order ID as an str, and we'll tell the shipping cost, and let's make it float. So let's say ASYNC def run. Actually we'll need to let me see, we have everything, okay, fine. And ASYNC async, we can pass on. Let's first make the run call. It takes the self async def context graph run context. It takes the order state and it returns an annotated confirmed end state. This is the exiting condition. Str, and the edge will say the order confirmed for the self. Let's make it fstring. What is happening? Order underscore ID. Oh, sorry. It is a base node and it takes the order state. Now this is correct. Graph run context, order state, it returns and str h. So what's the error? Let me resolve it quickly. And we can see the annotated str h label. Let's remove it for now. Let's only make it order confirm. Yeah, all errors are gone. So if context dot state is none, then you know context dot state is going to be an order state. If that is not the case, then we are going to update dot processing steps dot append. We'll say order confirmed for self dot order id, and then we'll say final. And this is where we'll update the context dot state dot order status as confirm, and we will update the state again dot state dot processing step dot append. Let's make order and we can print a message that this graph is done success, and we can return an end node from here, and we can pass confirmed. So this is the confirm order state. Now we are going to define the graph. So this is the order processing so let's use the graph. We need to define the nodes as validate order, check inventory, and we have process payment calculate shipping cost, and then after that confirm order state. And we also need to define state type as order state. Now we can execute. So let's make an async def function. So we'll have to create a test order, and let's do test order is equals to order state. Let's pass the values as order ID. Let's say it is ORD001, and let's pass customer ID CUST001, and let's pass the items. So we defined it as an array of dictionary, and we'll define it. We'll define two items, and then payment method is, let's make it credit card, and then shipping address. So this is a dictionary. I think now let's fill it with a value. So let's make product ID let's give it an ID of prod 001, and then it had a name because we have used it as MacBook Pro, and let's give it a price of $99. And let's give the quantity to be 1. Same way, we'll make one more order of let's say, so that we will hit the the chance of payment failure as well. So we can order one more thing as, let's say, mouse. That would be price at 29, and let's order to quantity. And next is the shipping address. We can copy this one. Let's copy it. We'll use the address, and this is one test order state. And what we will do, we will execute the graph. So because we have to define the first node, let's define validate order, and it takes the order ID as order test order dot order ID, and let's store the result. Let's make val node, validation node, customer ID, items, test order, items, and then we'll need payment method, test order dot payment method, and then shipping address. We can pass shipping address, and that's how we will now execute the orders graph ORDER processing what did we name it? Order processing graph dot run starting node with validation node, and we will print response dot output, and we can now run this code under name, then async IO dot run dot main, so let's see if it runs successfully. Is completed state. This graph is completed, and confirm, you'll get confirmation only when the res.output is confirmed, that is, it is going to the end state. In the end state confirm order just returns confirm. So we can do one more thing, as we can print the intermediate state at each level. So let's do one thing. Let's go to check. Before we go to check inventory, let's put our debug. Debug in well order. Let's see the state. Context.state, and we are going to do the same thing here as well, but it is check inventory. And calculate shipping, then process payment, and let's also do it here. This is calculate shipping. So the graph work is the FSM, and intermediately it has executed our business logic, and let's see if we can see the intermediate state as they evolve. Confirm order. Let's run it. See, this is the debug from validation order. We passed the order 01, customer, price, and all. You should see, look at the processing step, order is validated. Now let's go to other state, inventory, check for order, all items are available and inventory available is true. And then we'll go to process payment. This is the payment successful one, 1000 something dollars, and this is also correct. Shipping cost calculated because it's not an international one. So base price, confirm order, that's how it works. So let's play with it. So we made any special conditions of if the country, confirm order, calculate shipping. Let's go. To calculate shipping, and we said if it is in Alaska, so let's just make it Alaska and run this graph again and see if the state evolved to this shipping cost. Did we made it for any specific? Oh, actually we have hard coded it, so that's why it is always taking the, it's not taking the special case. But yeah, we can pass on the state as well. This is just an example like how you want your finite state machine to evolve as a graph. This graph would have taught you how to process in between the nodes. And the next, now we are going to level up our game. We are going to introduce the LLM calling, and specifically we are going to use AIs in such a way that it improves our current system. So the current system has a basic graph flow. We are going to introduce a LLM based vetting to look for any suspicious attempt to trick our system. We are going to implement our risk and fraud detection system. So for that, in the existing structure, we are going to add an LLM insight, which is a list of instructions, risk score, and fraud detection. Now we are going to create more agents and their respective tools to see if on each node or wherever it is required, to see if our AI can help us to prevent the frauds or prevent any organization who is using this e-commerce graph. So now we have created the order dependency that we will specifically pass to the agent who are going to analyze this. Now see, this is a graph dependency. We don't want to give whole information. We want a smaller subset of information. So we will use a order dependency here. Now we will same way, because we will be parsing the response from the model. So we need an output structure as well. So see, here we are asking agent, is this transaction is approved, risk level, the reasoning, and list of recommendation. Now for same way, fraud detection output, is it suspicious, risk score, suspicious pattern, action required. Now their field description is given here. Is suspicious, it is a bool, whether the payment is suspicious. Field risk score greater than less than 1. Suspicious pattern, if they notice something, then they are going to add. Same way for shipping recommendation. To recommendation shipping method, estimate shipping cost, estimate delivery time in days, reasoning for the recommendation. So this is the structured base model that we are creating. So now, if you have followed the previous tutorial that we have made on this channel, you know how to call the Pydantic AI agent. I am using free Grok version. You are feel free to use OpenAI one. So we are creating an agent using Grok Llama 3.370 billion versatile, and we are passing the dependency as order dependency, and order output is this one. This is the way we want our output. This is the system prompt, and it is instructed to provide the clear field like that. And then another is the fraud detection, and we'll provide it a tool. Later on we'll show you how we can add the tool. This is the fraud detection one, and it is using a smaller agent. Then this is the shipping agent. Now coming here, we are giving the order validation tool the access to database. Here I am mocking the database for each customer. I am maintaining their history, like how many order they have given, or average order value, last order days. So these kind of data typically organization have. So we are going to give our agent this access. So whenever any customer ID is being provided, our agent can retrieve this information. And for now this is just a simple get, but it would be in a production code. It will be a fixed ORM call. The other is the order validation agent tool. It calculates the risk of the order. So based on the amount, I have made a scoring method. Here if you see, we are adding the scoring factor. It is between 0 and 1. If the order amount is greater than 5,000, then we are increasing the score significantly. And if the order value is 1,000, then we are increasing risk factor by 10%. From the customer history, so now we are using cross tooling. Once we retrieve that the history is new, then we are increasing it's increasing the risk score. For customers history is suspicious, then we are also increasing the risk. So that's how our custom tool is being implemented. For like luxury item, if they are adding, then we are increasing the risk score. So that's how it returns. In the same way, uh, the factor and the query classification, like based on if the risk factor is greater than 0.5, then we are classifying it as high, medium and low. Now the fraud detection system so has the tool. So if the this is also scoring based method here, based on the amount, and we also know some suspicious customer, then we are increasing the respective since customer 003 is known suspicious, we have assumed it, but so based on that we have written the tools. Now shipping tool agent is going to suggest the shipping types: express, spend, standard, economy, based on the total amount that user has spent. Now based on the location, we are estimating the cost. So now instead of calculating, we are using our LLM to make these tool calls and get the proper estimations. Now this is our first node which we have written, that is a validate order. This is same, everything is same till you come to this point where this is where we have done all validation and all. Now we are going to determine, first we'll create the dependency for our agent from the dependency of this node. So here we are assigning all of the values that is required for the agent. Now this is the order detail that we have provided, and then we are passing it to order validation agent. Now order validation agent tells if this is approved or not to go for next state. If it is approved, then we'll go to the next node. If it is not approved, then we are going to end the node from here, and the reason is being order value failed AI rejection. Now we will move to check inventory. Now here you see check inventory is same. For now, check inventory we have not made any tool calls, so we'll go to process payment, where we will try to detect the fraud detection. Here we are again preparing the dependency from the existing uh, dependency of this node. We are preparing the prompt and then running the agent, and then this agent is going to tell is it suspicious, risk score, pattern, and then if it is suspicious, then we are going to end the node. And if it is uh, based on the LLM, then we are like breaking this chain. So same thing now for shipping agent, we are now getting it calculated from the shipping agent that is going to call the our database and retrieve the values. So just everything is same, it's just that we made our nodes little smart. So now I'm going to create two customers. So one is the normal order, where order 001 customer 01, they have purchased these items, and then the customer 003. So we hope that this customer will get flagged, and let's see, after running this, let's run this. Here we run ecom, we should see our agents are validating the results. All right, so here you can see order 01 analyzing the validation for order 01. It says it is approved, risk level is low, the customer has trust history with 15 orders and an average order value is 250. This is what we have stored. The current order is moderate, but customer history suggests they are likely to pay. And luxury item, past behavior, they trusted, purchase, so Pydantic AI approved. So that's why this order was completed. Now you can ignore this error. For order 002, we can see, since the customer has been pretty much same, here you can see the risk score level is 0.2, which customer has a moderate number of error, high value, which suggests that the customer is active and trustworthy, so amount is moderate. Now let's see if after resolving that error, actually the model was not correct. So just change the model from 3.8 billion to 78 billion parameter. Now we are getting the correct result. Now look at the order 2. When analyzing, it approves the customer has suspicious in one day. However, the current order, which is below the average order value, so risk is low. Now it goes for uh, the risk score and unusual order amount, suspicious because this is customer 003, it has a suspicious customer behavior, so action required is review, so payment flagged for review, and we did not completed that order. So that's how you are going to make the this is how you are going to integrate these into these graphs into Pydantic AI agent, and hopefully you have learned something from this session, please do not forget to like and subscribe. Thank you. I'm going to push this code in repository and link down in the description of starting the LangGraph series. And we have just completed the LangChain one, which is the basics for learning this new series. So I recommend you to go and check out that first, and then we are going to build some advanced agents. So without further ado, let's start LangGraph. So first thing first, let's learn about the memory management. So for that, from LangChain core dot prompt, we need to import the chat prompt template. So chat prompt template. So this is the same basic LangChain stuff, but I'll tell you why it becomes important. So from LangChain OpenAI, import chat OpenAI if you are using directly from OpenAI, or we can use I am using, in my case, using from Azure. So everything remains same, just the object we have to import different. Now from .env, import load.env, and let's invoke it so that our environment variables are set up properly. Now let's define the prompt. PR. I hope that is visible. So from chat, from template, from messages, and then we have to give the array of messages. So if you remember, we used to give the system and the placeholders. So we are going to do the same thing. Let me give you here. You are an helpful assistant. Answer all of the question based on your best ability. Question to the best of your ability. And in placeholder, then you define the placeholder, what would be the message. So now let's define the LLM. It is going to be Azure OpenAI, and we can define the model as GPT-5 mini. I'm going to use the GPT-5 mini. So now let's create our first chain. Chain is first prompt goes, and then the model. It's LLM. And then let's invoke it. So chain dot invoke, and here what the placeholder that we have made, we are going to fill that, and let's pass messages as the array, and let's pass human AI and human message. To speed up the things, I have already written in my notes. So this is going to give us a response. So let's print this. Print response. Hopefully everything looks fine. LangGraph memory. Okay. Sourced. Now let's run it. Okay, so it throws an error. List has no attribute. So I think I miss. Is it this correct spelling? From messages, placeholder, human AI. Okay. Let me paste it here. Let me see what happened wrong. Azure Chat OpenAI model is 5 mini. Now let's run it. So translate this sentence from English to French. I love programming, and this is AI. What did you just said? I love programming and English back. So yeah, so that's how this is just a refresher. Like, this is how we create, we can understand as we create the human messages. Now the next thing, the important thing that we are going to learn from here is the concepts of LangGraph. So we create a file, we name it state, and let's try to bring this much code from here and bring it over here. So we need to, now you will see how can we pass on the information as the states of graph. So let's, for the first thing, let's define a state which will take it from typed typed. Let's support it, and messages annotated list add message. So what it will do, it is going to append all the messages as it happens. So now we need to add the dependency of LangGraph, because we are going to use this aggregator perfect. And now we can import this from LangGraph import add message. What it will do, this state will append the messages as it gets, and the type of this field is this is a list. Now let's define the builder, like how. So let's make builder, which is a state graph. We'll also need to import it from langchain.graph. So this is the state graph builder, and here you will pass your state. So we just passed our state. I mean, based on this state, build a state graph. Now let's bring our LLM, Azure Chat OpenAI. Our model is 5 mini. And now we have our LLM. Let's build our chatbot. So let's define chatbot state. It's going to take a state that we have just defined, and it will collect the response while invoking it. LLM.invoke, and we need to pass now the state dot message. See, we were getting the type hints because these all are parenting models, and we are also again going to return the same format messages. And what you will see, as we what as we interact with this chatbot, the memory will get built up for this graph, because we have defined it in such a way that as soon as any new messages will come, they will get appended. Now let's use our builder. Let's add a node because it's a graph. So we need to define the node. So let's make chatbot. There's only one node. This is the node, and then there are multiple edges. So builder dot add edge. So we have to, there's something, there's always going to be a start of a graph. So let's import it, and then the same way there's going to be an end of a graph. So we can add start to the chatbot, and then it's also add an edge from chatbot to end. Now once you're done connecting your graphs, you can then go ahead and compile it. So let's graph builder.compile. This is going to compile your graph, and then to run this graph you'll have to pass the messages the way you wanted. So let's define the input messages. It's a list, and here we can pass human message. So let's import this from the LangChain code.messages. Import human messages, and then we can pass on here human messages, and let's start with sending a hi. Now let's see for chunk in graph gp dot stream, and then we can pass our input, and then we can print the chunk. Let's run it. LangGraph state graph. Perfect. You can see our chatbot has responded. Hi there, how can I help you? I can answer question. And let's do one thing. Let's only print the content. Content only. Okay, so with chunk we can't take this. Fine, let's run it. So this chunk is chatbot messages. Let's see if we are able to parse it. Perfect. So I think I need to go chat bot, and then the messages from there. Let's try to get the first one. Perfect. So that's how you can parse it. Then you can go dot content. So this is, I mean, based on the response of an AI, you just print it and you'll be able to learn it. No need to remember anything. So chatbot, messages, first content, and then the content. This is where you get your output. So this is how you build your first state graph with the help of LangGraph. Important thing is we learn like how to start a graph, how to end a graph, how to add the edges, how to build the nodes, and you have also seen me making some error, how to fix them, how to build the states. These are the important things that someone needs to remember while they are building the graphs. And in the upcoming session, what we are going to learn is how, because right now if you see, as soon as I run it, it lost its memory, but we'll learn how can we preserve the memory, the persistent memory saver of the LangChain. And from LangGraph, there's called something called checkpoint.memory, which we are going to use for the upcoming session. Thank you. Till this point, we just learned how to make a graph. Now let's learn how to make a persistent memory. So doing that is actually very easy. The one way is very easy that I'll teach you. So you just need to import in the same code langgraph.checkpoint.memory. Let's import memory saver, and we are going to use the same state and same builder. Let's use same model. Also let's use same node. This is also going to be the same. The only thing that is going to change is when you do a compilation. There you can define your memory saver checkpointer. This is what we are saying. We are saying add the persistent sense with the memory. So let's make a thread 1, and it is going to be in this format. Is going to be, you need to define the configurable and the thread ID. So it can be a UUID. You can provide any ID. It should be unique one. Now the way you are going to invoke your model is going to be different. So let's comment this out, and till thread we just added the thread one, and let's bring our first AI message. So here you can see we are calling just the same thing. Hi, my name is Jack, and this is the thread ID. So if you remember, if you invoke again, the model will lose the context of previous message. Let me run it. Now without this thread, if you are going to run it, and then if you make another invocation, let's make it result 2, and we'll ask what was my name, and we, as long as we provide the same configurable, then we can ensure that model will have this memory context with it. So let's run it and see if it works. Perfect. Hi, my name is Jack. This is the human message. Hi Jack, nice to meet you. How can I help you? Now, this is the second message. You said your name was Jack. That's perfect. Now, what happen if I do not pass this thread and then run it? Alright, we need to remove this as well. We need to compile it without checkpoint. You'll see the difference. This is the first message. After that, we'll have second message. If we are interested, what was my name? I don't know. You haven't told me your name in this conversation, and I don't have any just the differences. We just passed the configurable memory savers thread point, and that is the only difference that it made for the memory management. This is the one of the ways of doing the memory management, and it's very helpful if you want your uh, model to retain the context of the conversation like in a chatbot system. So this is how you are going to do it. Thank you. For training our model, we are going to use a synthetic dataset that I have generated, and the file is also present. I'm not going to code it. You can get it from the GitHub of this code repository. So it has 12 columns, and it takes the smartphone features, and it returns what is the probability that this exact specification will get returned. So for example, given brand condition, is it open box, new, refurbished, RAM, storage, carrier, discount, rating, or number of days since it was first purchased. Based on that, we tell whether it is the probability of it getting returned or not. So this data set has about 5,000 data points, very small data set, and it has about 17% data which has a high return rate. So let's quickly learn how can we write code with MLflow. So first thing first, we're going to install the dependency, which is uv add MLflow, and we also need the scikit-learn because we are going to use the simple random forest. And let's also install pandas and numpy, matplotlib to visualize the performance of the model, seaborn, let's install it as well, plotly, Jupyter IP kernel. kernel. Let's give them a bit. It's installing all the required dependencies. Meanwhile, let's create the model. I have created a separate folder for the first episode. Let's make it train baseline, because this is going to be our first model, and let's wait for it to get installed. And there we go, our model has been installed. Let's spin up the MLflow UI. MLflow UI so this will start the MLflow UI, and this is how your MLflow UI will look like. There's no experiment right now, no model. This is clean slate. First time we are adding the MLflow. Now let's do import the dependencies. Let's import matplotlib.pyplot as plt from sklearn.compose import column transformer from sklearn.ensemble. Let's import random forest classifier, and from sklearn matrices import accuracy score, F1 score, ROC AUC score, confusion matrix. From sklearn dot model selection import train test split. From sklearn dot pipeline import, let's import pipeline. From sklearn dot preprocessing import one hot encoder, standard scaler, and from MLflow dot models import infer signature. So now let's define the directories let's also import MLflow. And we also need OS. Import pathlib from path import path, and let's also import MLflow.sklearn, and we have to import numpy as numpy, import pandas as pd, and I think we are good. Let's define the paths. Let's define the root of this project as path dunder file. Let's make it parent. This is going to be really helpful because I believe you guys are running this code on Windows, Linux, anywhere, it is going to work. So what I am doing is I am telling it from root, in that same folder you're going to find the smartphone, SMART PHONE .csv, and now let's define artifacts. Let's also save them in the artifact folder. Because the ML processes will generate some artifacts, and let's also make right away, once this code execute, let's make the directory and exist is equals to true. If this if this directory already exists, then we are going to skip it. Now let's do the MLflow setup. So let's do one thing. Let's MLflow set experiment. Let's make it as model baseline, or let's do, since we are going to refer multiple episode, so let's make it episode 1 baseline. It is going to helpful because we are going to use the same model in the coming up series. So let's load the data. So df is equals to pt.readcsv, and we can pass data, and then we can split. df.drop, let's drop the last column. Return, and the label is df returned as type integer. These are our features, this is our target. Now let's bring the numerical column separately. Select t types, include numpy dot number dot columns to list. So this way we will be automatically getting all of the numerical column name. And then let's get the categorical columns. Select t types, exclude. Again, if we exclude the numpy.numbers, then this way we'll only get back the columns to list. So now it is going to help us in identifying the numerical and categorical column. You don't have to hard code anything. We'll try as much as possible to prevent hard coding. let's do pre-processing. Pre-process column transformer. Now let's transform. Let's build first the numerical transformer. Numerical. Let's do standard scalar, and we can do with mean is false, and let's pass all the numerical columns. So next transformation we'll do for categorical is they will be of one hot encoded, and we can say handle unknown as ignore, because since I have prepared this dataset and I have made sure that there is no unknown value, and we can pass the categorical column in this. Let's try to run see if any error that comes up. Episode 1 train baseline. Hopefully it will work. So meanwhile, let's build our model. Alright, there is an error. Smartphone returns. Maybe I have written a wrong name. So let's do it again. Yeah, so there's no error. We can continue building the model. So let's model an hyperparameter. So let's define the number of estimators. So let's do integer os.get, or we can, usually these things are passed as a environment variable, but for now let's make it 200 max depth. Or let's do one thing. I'll do the code that goes in the production. So os.get env rf and estimators, and if it is able to find it, otherwise we'll give a default value of 200. So that's how, because we want to make it configurable, that's the idea. Integer os, there are other ways as well, like you can pass it as the argument. Get env random forest max depth. Let's take it 12 if it is not provided, and let's give random state. Now let's define the model as random forest classifier number of estimators max depth is going to be max depth. Random state is going to be random state, and let's give number of jobs as, let's take it -1, and we can define the class waste as balanced. Now let's define the classifier as pipeline. Its steps are, first the preprocessing. We'll use the preprocess that we have defined here, and after that it goes into the RF, random forest. Let's pass our model. So this is an array. Perfect. Now let's call our train test split. So previously we have splitted the features and target variable. Now we are splitting the data. X train y x test. Train test split x comma y. Let's give the test size as 0.2 and random state as random state, and stratify y. We want to do the stratified sampling. Now this is the traditional machine learning writing way. Apart from that, we just had done an MLflow experiment setup. Now we are going to use with context for MLflow dot start run, and let's give the run name as baseline random forest, and inside that we are going to logs the MLflow parameters. And MLflow dot log param and estimator is an estimator, and max depth. So that way we will have the track, like for that this experiment, these are the hyperparameter that were used. So now let's run our classifier fit x train and y train, and then after that we'll do the eval. So let's get the predicted PRED CLF dot predict y test, sorry, xtext, and let's also get the probability. As for now it's none. Let's do try and catch. So y probability CLF predict probability x test everything except exception. For now let's pass it. So now we'll have the probability, and that will be helpful in calculating the ROC AUC. So now let's get the accuracy. Accuracy score. Let's give y test and y predicted, and let's calculate the F1 score. Y test, y predicted. So MLflow dot log metrics. This is a metric. Earlier we logged the parameter. Accuracy is and MLflow dot log matrix F1 is float of 1. Now if y probability is not none, then we can calculate the AUC, ROC AUC score, y test, comma, y probability. MLflow log metric C float UC. Now let's draw the ROC curve. So let's import from sklearn dot matrices, import ROC curve display, precision recall display, and we can as plt dot subplot fig We can define the figure size as 5,4, and let's get the figure and axis. Figure ROC, figure axis ROC. And then ROC curve display from predictions y test, y probability, and axis is axis ROC. So we can give path. We can give the path as artifact. After that, it will take ROC curve .png. Now figure ROC dot tight layout. Dot savefig ROC path, and let's give the DPI of 160, and then we can plt dot close the figure. Figure ROC, and we can log the artifact, the MLflow, log artifact as str of ROC path. And that's how you save the model performance. Now let's do one more thing, and let's save like artifacts. Let's give the information of class balance. Y dot value count, normalize true, rename access to class, reset its index, and let's give the name as BCT. Class balance path is artifacts / class .csv to CSV class balance path index, let's make it false. Now MLflow log artifact, we can give the name str str of class balance path. And one more thing is the confusion matrix. Confusion matrix we can calculate as Cm as confusion matrix, and we can pass y test comma y predicted values. PLT dot subplot let's give the dimension of 4 cross 4. Then AXCM show and then we can put CM CMap, let's give it blues. Set X label predicted values AXCM dot we can give y label as actual. And now we can enumerate for I comma j comma v in np dot nd enumeration cm. So AXCM dot text let's give the HA as center. These are the just formatting, and VA also as center. And we'll also need to give the color bar so that it's visible and then CM path you can define artifacts /png figure cm same thing, figure cm dot save fig. Then we can close the plot. Once that is done, we can log the artifact and str dot cm path. Finally, let's log the model. So let's infer the signature. Extreme.head. Let's log 5 examples of input. Infer signature will pass the input examples. clf.predict examples. flow.sklearn.log model clf name, let's give it model. Signature is signature, and then input example. Let's also add a print statement. Accuracy is this, and f1 is, hopefully this is going to run. So there is error at subplot. Alright, let me define this way. Fig Hopefully this is the last error. So CLF name signature, it's log model, not load. Let's see. Yeah, so model is trained, accuracy is 0.81, and this is the F1 score. Let's see our MLflow UI. Look, this is the experiment that got saved, some failed runs, and the final one, which is the success run. It is giving the information and all artifacts. See, all of them are getting saved here. That's the nice thing about MLflow. And this episode was more on the MLflow artifacts, and in the next video we are going to learn about how we can do a train sweep in the MLflow. You can see all of the matrices that are logged here, and yeah, that's pretty much for the first video. I hope that you were able to learn the basics. Thank you. Welcome back, episode 2. So now we are going to use same dataset with better workflow. So the idea of this video is we want to do less and we are going to log more with the help of auto logging and evaluation. We will add, in the last episode you have seen we have done lot of manual auto logging. This time we are going to use we are going to run multiple random forest model training, each with their own config and with their own full pipeline, and we are going to actually track which part of dataset are being used for what model, and we are going to learn about MLflow evaluates. So here is the code. This time I have copied the some lines from here. This is some configuration that I have done so that we have switched the folders. Usually we don't do that, but I am trying to get the same reference to same artifacts and all. So let's start with the train sweep code. First thing first, let's also get the now for this we will change the experiment name as episode 2, and let's give it a name of auto log. Now let's read the dataset, and since we are going to use same pre-processing, so let's also take that code. And now let's enable auto logging from sklearn. So log input examples, Yes, we want to do log model, and let's make it silent. Let's prepare a small sweep of configs. So estimators, let's define one as 150, maximum depth as 10, so let's train different model with 300 and depth of 12, and let's define one with none depth. For now let's keep only 3. So now let's make a variable that holds the result. With MLflow dot start run, let's give the run name rf sweep parent as parent run. Let's give the dataset train MLflow data from pandas. Return as filetrain. Let's also first copy the train rest splitting. And after that, let's give the source give the name smartphone returned train and then we can do MLflow log input. Dataset train. Let's give the context as training. For now, let's print the error if any error occurs. Now let's iterate for each config. With MLflow dot start run and run name, let's define as random forest cf config number of estimators times config max depth. Comma nested is true. So these are the child run. Now let's build model from this. Random forest classifier, number of estimator is config number of estimators max depth config and we can go with random state as random state job as -1 class weight is balanced, so CLF will be pipeline steps. First step is prep, where we are going to preprocessors. After that is the random forest, just the same thing that we have done. It's just we are running multiple nested. So now fit and evaluate. Xtrain, ytrain, now let's calculate the accuracy score. Y predicted, and also let's get the F1. same thing. So let's log the top line matrices manually, and so that we'll also know, because some matrices we wanted them to be always present. And let's F1. F1, and also let's MLflow set. We can set the tags this time. So let's give it the stage episode 2, model family, random forest. Let's give it one other tag, purpose. This is hyperparameter sweep. Now let's get the automatic. Same thing that we did for training. Now we are going to use MLflow evaluate. We'll pass the classifier. After that we'll pass data. After that here we have to pass the data frame. And then targets, model type, it is a classifier, and we can define an evaluator. Let's use the default one. Let me check if everything is fine. All right. if there is any exception. And so we will also append the results. So let's get them. This is CFG. I think this is done. Now let's try to run it. So to train sweep. So it is creating model. Okay, let's see if we get the auto sweep. It was successful. With look here, it is showing the data, all of the information. Now this is the parent one. Here you will see the child one. So if you click on this plus icon, now you will see everything, the tags that we have defined, the training scores, the preparation pipeline, and criterias, transformation. All of the information are being auto captured from here. Model matrices and the artifacts, precision recall curve, everything for all of the runs is available. Evaluation dataset is also, training dataset information is also available. So that's how you do proper experiment tracking with parent and child nested runs. Yeah, thanks. How can we do the hyperparameter sweep? We had trained 3 different experiments with their different configurations. Now this is the time where we need to select the appropriate winner model that we are going to use in production or stage. So in this video we are going to learn how can we register a model, and then how can we promote the model to appropriate staging, production, and also how can we retrieve any model meaning using their production stage alias, we are going to get the model and do some inference from it. So if you have been watching this video for first time, this playlist has 2 more videos. Make sure to watch them. So this time I have written the code because otherwise it will become a very big video. So if you remember from our train baseline, we are doing the same thing. We are just setting up everything, as you can see. Now this is the main function which is responsible for getting an experiment. So tracking URI will be same for all, and it is going to create a client using MLflow client. We have instantiated a client object, and we are getting a specific experiment that we have done. So we will be retrieving this experiment that we have done, and we are trying to register our model from there. So once we get the experiment, then we are going to do a search. So from this experiment ID, get all of the F1 scores in the decrement order. So we wanted the best model, so we are getting this is a condition. I mean, we can get all experiment, but we are getting on basis of some conditions. So we have calculated the F1 manual score. On the basis of that, we are getting the runs. So let's collect the first run, because from them best F1 score will be the best model. So let's collect the best model. We need to in the best model you have info, and you get the run ID, and using that run ID we will take the model name that we want. It's smartphone return RF, and we are going to register that model. So once this is done, we will get the MV model, and we will get the versions by dot version, and we can also then set the alias as best with that model version, because we will set from this experiment whatever model have the highest F1 score will get the alias of best. So upon running this script, we should see a model getting registered. So let me run it. So let's run this code. So here you can see we got the I have actually run this code one more time. So if when you will run, it will get created with version 1. Since I am running it second time, then we are getting the model as version 2. So if you go, you see the model has registered with version 2 and alias as best. Its input characteristic is present, like which are the signatures, which are the feature vector it needs, and the output that it generates from this model. And then you can go to the source run artifact. Everything is present over here. Its estimator, peer curve, and everything is present over here. So this is how you do the registration. So this is the first step. Now moving on to next step is the promotion. So in production scenario, you're not going to change your code. You will be referring to the production scheme like staging, or people also say it pre-prod. Then we go to prod environment. So we need a way so that we can pick the best model and then first promote it to stage, and next if it satisfies the criteria, then we can promote it to production. So first thing first, this function is just a helper so that we can reuse this same function to send this model to multiple stage. like staging, production, or archive. So from here again same rule, you set your tracking URI, MLflow client, and then you create a client. Now what we need to do, we will collect information from user. Like right now I'll give the user that which model version that you want to get. So because we want the always the best model, to anytime we do any experimentation, from that experimentation we want the best model. So let's retrieve the best model, and we need its version. Otherwise we can also provide the version, that's also possible. Then in the MLflow client there's method transition model version stage. You need to provide the model name, which is the same thing, and then the version, which version, and then you need to at what stage you want to promote. Right now the existing version usually get archived, so we don't want that. We want to give that model as well. So once this is done, it is going to promote it to any desired elevation we want. So once that is done, then we are also going to set the alias for that model. And let's run this code. Now this is how, at what stage. Let's first promote it to staging. So you see alias staging v2. Again why v2? Because we are I had run this before. From v1 it will elevate to v2, because now v2 version is the best one. So v2 has been moved to stage. If you go v2 version 2 and you see staging, it has been promoted to stage level. Now same thing, you just need to provide next thing. Let's test for the production. So let's move this to production. Promote model to production. So v2 has been moved to production. Let's see. Now it has the add production alias. Now whenever you are going to make any API, so there you want to ensure that you always refer the production model. So how can you ensure that you always load the production model in your API? So for this I have created this file which is going to load the production model, and it is going to do some inference. So same thing, MLflow set the tracking URI, and from there we will use MLflow sklearn.load model, because we have got our random forest model from sklearn. We are going to give the model URI, and this is just the helper function which is going to read some sample inputs from our dataset, and then it is going to do the predictions, model.predict. So let's see. So let's see. Yeah, so it has loaded this model, smartphone returns, random forest, production, and this is the first 10 predictions. So 0 means it won't get returned, 1 means it will get returned. So this is what is expected, and this is how you do model management in MLflow. And you can see this model from this sweep, this model has got been getting promoted to you can see this model got promoted. Now in the next lesson, how we are going to learn about how can we validate and promote on basis of criteria. Like this is what is called champion challenger based schema, where we are going to create a condition, and on basis of that condition, let's say any F1 score or AUC score, we are going to do like next because next time when you are going to run the experiment, you again will get best model. So then you already have a prod model. You wanted to ensure that the best model beats the production model, then and only we are going to accept it as a production model. So in the next lesson we are going to learn how exactly we can achieve this, and thank you for watching this. So we have learned how can we promote, register a model to production, and we have also register a model smartphone return RF to prod. Now we are going to learn how can we enforce the equality gate before promoting any model. So compare a candidate run or model versus current production or staging using matrices or statistical check, then only promote the model. So if you remember in the last video, I have been providing the input like promote this to prod, promote this to stage, but not anymore. We are going to learn how can we ensure this decision are being made statistically. So for that, what I have created one more file, and this is called validate and promote.py. So we are going to again use our same data set. So this is the some configuration, and we have imported the matrix calculation of F1 score, ROC and accuracy score, because we are going to do the calculation. And we have defined a helper function which takes the model, because we will be reusing that same function to do the prediction from best model or either staging or production model. And it takes the feature vector and the labels, and it is going to call the predict so that we get the predictions. And we will also try to retrieve the probability so that we can calculate the AUC scores, because it needs the probability. Once this is done, we are going to return the matrices. Now we are going to ask user who is going to run this program that what is your candidate aliases. Right now this is always going to be best. This is a one-time decision, or in future if you change it you can refer it. So best is what referring the best candidate from a run of sweep. So you remember we have trained multiple hyperparameter models and we got a best model from there, and then you refer your production, either production or stage, however you want, and the minimum F1. So you wanted like what is your criteria for promoting the best model when it perform minimum 10.10 F1 score better than the production model, and same with the minimum AUC, like this much AUC has to be there. So and there is another like promote if better. This is just because in some time our feature vector changes, then we don't want we actually want to promote the model irrespective of the matrices. So those cases also tackle here. So if now you must have remembered, like first thing first, we need to set the MLflow tracking URI. Let's read the dataset, and then let's get the candidate model, candidate alias and base alias. So we are getting it from here. Baseline alias is the prod or stage. So this is always going to be the model which is in your that you want to replace. So it can be possible both stage and production have the same model. So from sklearn, let's load the candidate model. Let's get the evaluation, passing it to this function, and then we get the candidature aliases. Then let's do the baseline one from prod. Let's load it and let's get the baseline one. Now let's prepare the gates. Let's see if it is passed or not. Now if we have just written a conditional, you can make your own conditions. I have made the condition in such a way that if there is any F1 score and that F1 score is greater than our minimum, then is less than the minimum, then mark this as fail. Or if AUC, so these are the minimum checks that we made. Now if the F1 of the candidate model is less than the baseline model, then also we are not going to pass. So this code actually work as a gate that fails the promotion of best model to prod, because by default we are going to make it pass. If not passed, gate is failed, not promoting. And then if this is not the case, then this is how you do switching. So MLflow client, this you get the client, you get the alias of the candidature model, and then you just register that alias as production and you set the version. This is how you do the promotion. So this is how you do a statistical way of promoting any model. Now let's run this code and see if it works. Python validate episode 4, validate and promote. So let's pass the candidature alias. Let me get it from here. So we can pass, let's take the promoting model as best and then base alias. Let's try to replace the production model and let's run it with the default values. You can see we were able to pass the gate, so we have promoted the production model to version 2, which was already there, but gate still got passed. So this is how you do the model promotion. The promotion logic could vary depending upon the use cases, so you just need to figure out how you can retrieve the models and their matrices, how can you calculate them, and then you just build a gate. This is a fairly design problem. Here your design matters a lot, how you want to achieve this. You just need to know that the method of doing the promotions. In the next video we are going to learn about how can we do batch score in production, and we are going to continue this, because the goal of the next video is to use production model to score new data in batch, log their predictions or any artifact, and we are also going to run our lightweight drift detection against training distribution. So this is how a real world scenario where your model over time degrades its performance. So we need to ensure that we detect the drift. We are going to learn in the next video how we can achieve that. Thank you. Video we have learned how we can statistically promote the model. Now in this video we are going to learn about the drift detection in MLflow. Over a time we want to calculate how our model performance is getting degraded or not. So this is also very important in the MLflow lifecycle. We need to detect as early as possible if the model is getting drifted away. So we are going to take inspiration from our previous codes, and I have done the code explanation in the episode 1, so feel free to watch it. why these configurations are set. So once this is done, your configuration, set the MLflow tracking URI, and this time we are going to set new experiment, which is batch scoring. Right now we have only 2 experiment, and here we have done the model sweeping, simple model train, model promotion. Now let's collect some data which we will use to check for drift. Usually this is a new live data that you might have labeled, or in case of unsupervised learning, unlabeled data that you will take. For now I'm going to use the same data because we want to learn the method. Data can be anything. Now you need to enter into the with context. You need to provide your run name. MLflow will start the run. We are going to specify which model for which we want to do. We have been using the smartphone return random forest model. We had trained it. We have done experiment with it. Now let's collect that model. The next sklearn model loads that model, makes prediction on the X that we have collected, preferably the drift data, and then we are also going to collect the prediction probabilities. Once we get this, let's save the predictions as prediction data frame, all the predictions that we have got, and also the probability, and let's save the prediction in a CSV file because this is a auditable artifact we are creating so that anyone can refer it later on. So let's save this and log this artifact in MLflow so that it can be visible in the UI itself. Now let's do a simple drift check. Let's select include all numerical data column, and let's do the collect some of the reference window. Let's mark some of the reference window as drift and leave other windows as usual. This is where we are calculating the mean of those columns, numerical columns. Then we are going to subtract it from the normal one, the drifted one, subtracting the normal one, and then we are doing the calculation, the feature, mean, current mean, delta mean, reference, standard, deviation. This report we are going to save it as the report.csv, and then we are logging the artifact. Now we can this is a quick drift flag. Any large relative mean shift, we are going to flag it. So we are simple logic is drift from diff df mean will check if multiplying by 0.2 reference standard is it standard deviation is about 20% about the mean. If this is true, that is mean we have been drifted away. Then we'll calculate the drift ratio, and then we are going to log that artifact. So this way you will be getting the information of whether our model is getting drifted away or not. So let's do this and let's run it. And for running this, let's Python drifts batch score. So it has created new experiment, batch scoring. Here all of the drift informations are present, all of the artifacts, drift reports, predictions are present. It happened really fast because the data was very low, and also this report can be audited with more webhooks enabled to also trigger the training so that you get new model experiment and then you redeploy new model. So from here it's a design choice. You just need to remember like how can you achieve this. Thank you. We have been working with model, how we can detect the drift, promote them to production. Now we are actually going to learn how we can build and from using MLflow how we can serve the model as an API. So to do that, it's fairly very simple, because all you need is you just need to know the path of the model, and then you can do the MLflow serving. Let me show you how you can do that. So if you remember, we have registered the model as smartphone return RF, and let's serve the production model. So this is how you can do that. Type MLflow serve -m, that is model, and then name of the model. So let's copy the name of the model, this model, and which version of it. Let's use production, and we can specify port on which we want to run this API. And for now let's use the same environment as the local one. MLflow model serve -m models -m model path alias, we are going to use production, and let's use the local environment. So this should spin up a API server, and it says at this IP and port it is listening. So what MLflow does, it has loaded the model, and then after that it has initialized the API. It's running on 5001 port. Now let's do one thing. We have created a client code which is going to hit this endpoint /invocation. This is where we do the predictions, and what we'll do for now, we're just going to read our dataset and get some records and make a post request to this endpoint and see if this API responds back with the 200 status code, or it returns any response. Let's see. We are in the folder. Let's run Python client. Yeah, so it returned the status 200. That means we were able to hit this API, and you can see the backend log. It got hit with the 200, and we got the response as the predictions. And see, we have sent the batch request here, so we were getting the response as well. So this is how you create an API from your MLflow production model, and this is just a simple client that invokes that API. Thank you. We have built our foundation of machine learning with the help of MLflow, and we have completed about 6 core concepts of MLflow. Now I am going to teach you an interesting way of writing MLflow code for generative AI applications. One of the most important thing in the field of AI engineering is the tracing, because you want your system to be maintainable and you you want to have control over every aspect of the processes. Here, MLflow helps really to establish the tracing of any tool call or LLM invoke from any side, either the client or server side. On our channel, you will find the Pydantic AI agentic tool. Sooner, I am going to upload the LangGraph as well. For now, what we are going to do, how can we use MLflow to make sure that our tracing are being done. So first of all, let's make sure that your MLflow server is running. So let's spin it up and let's see. So this is how our experiments are looking like. We have registered promotion model, and now let's see how can we do the tracing. So let me create a folder. Okay, so let's do some setup. Let me copy some of the code from here. Now, let's prepare a new experiment name. So let's keep this name as, let's name it tracing, and let's use Grok so that everyone can follow the tutorial for free. It should not cost $1 for learning. So let's also import Grok. Let's install. Make sure to install the Grok dependencies. So as soon as this is done, now first thing first, for MLflow we have to set the experiment. By now you must have learned it. Now let's do it from MLflow. Let's also import MLflow. So MLflow.setExperiment, and then we will set exp as the experiment. Now let's define a function where we will do the LLM invoking. So let's define a function. We'll do same thing. Let's define a main function, and then you need to add this line. From here you need to add, let's prepare before in usually any LLM call we prepare the client first. So before doing that, we will enable the auto logging for Grok. Auto log, same way we do it for machine learning, here we are also doing it. So now .grok, we have prepared our client, and now let's invoke this. So client dot chat dot completion dot create, and then model. For now, let's use llama 3. Llama 3, 8 billion. I think its contact window is 8192. We'll check it on the Grok website. And then let's go messages. The format for this is role and then content. So let's define role first. Let's make it user. And then we are going to define the content. And let's pass it a prompt. Let's ask this a question. Explain what is MLflow AI. Now, once we get the message, let's parse it. Going to the messages. Dot choices. Get the first one. Dot content. And let's also print it. See if it works or not. So let's first thing first, let's see. Try to build if it works. Let's go to Grok. And I will create a new API key. I'm going to invalidate this API key once I'm done recording. So do not share your API keys. Let's create .env and let me paste this API key and let's see what does Grok wants from us. Let's look at the implementation and API key. This is the way they will be looking into the environment. So let's go there. So and now coming here, we'll need to also from .env. Okay, let's add it. .env load load.env and then load it. So this will set the API key and we should be able to run this code. So let's run episode 7. Tracing. Yeah. So you can see we were able to make the call, and if you look at the MLflow logs, experiment with does not exist, creating the new experiment, which means now we should be able to see the traces in the UI. Yeah, there you go. Now let's go to traces and let's see the traces. So we were able to capture the model. What prompt was that? And it creates an ID. And what response we got back. create a timestamp object that it called, and the usage, chat completion, prompt token, token completion, prompt time, queue time, total time. Yeah, so this is how, because we just made an simple invoke, we were able to retrieve this much information. And once we do more tool calling and all, then we will be able to see the tool calling as well here. So for now, let's only keep the invocation and try to retrieve now information from the MLflow, these information that we have logged. Let's see how can we get it. So once we are done, let's try to get them. Let's put that in a try catch. Usually it's good practice to make any invocation in a try catch. So let's retrieve the last trace ID, and let's make MLflow get last, I think it is last active trace ID, because if I'm going to run this code, it is going to create new ID, and then I want to capture that ID, and then let's collect the traces. MLflow get traces. So we need to pass the trace ID, which is last trace ID. So let's print the total usage. And let's collect the trace dot info dot, let's now only collect token usage, and let's print this total usage. And this is how we will be able to retrieve the tokens, except exception as E. In that case, we are going to print the exceptions. Let's see if we are able to retrieve the usage. Alright, there you can see from our MLflow server, we were able to collect the token usage, output tokens, and all. So this is how this is the basics of MLflow tracing. I wanted to include that in this playlist because just wanted to ensure viewers that you can also do tracing and all with MLflow. We will go more deep and dive in the MLflow AI itself. We'll create a playlist and organize all of the content separately there. And we'll keep this playlist for machine learning, MLflow related, but with the hint that we can do traces as well. And with that, I conclude this playlist, and kudos to you because you have been looking for a true knowledge, not for an AI hype. And there are very few people who understand the importance of these lecture, but those who do, I hope that it helps. Thank you. Thank you very much for viewing this playlist. Transformers changed the game, but they have grown. So has their appetite for memory, for compute, for everything. But what if we could keep the brains without the bloat? This is where mixture of recursion comes. Today we are unpacking a bold new architecture that might just let your LLM think smarter without thinking harder. So let's rewind. Transformers are incredible. ChatGPT Gemini, Claude, they all use them, but there is a trade-off. The bigger the model, the more expensive it gets, and that cost it hits twice, once during training and other at inference. Now researchers have the two main ways of fighting it. One is the parameter sharing, that is reusing the layers, and adaptive computation only works harder when needed. So the challenge, most model only picks one of these, but mixture of recursion or MOR says why not both. So MOR is a recursive transformer. Imagine a single stack of layer reused multiple times, like running your brain's thought process in a loop. Now the twist, MOR does not treat all tokens equally. Instead, it routes each other token through a different number of loops based on how hard it is. Simple word exit early, complex stays longer. This is called token level adaptive recursion, and it's done via something called router. So think of it like your brain saying, this word is easy, skip ahead. That one needed more thought, loop again. So it's smart, right? Now let's break down the router because they are doing the heavy lifting. There are two strategies. Expert choice routing, each recursion blocks selects which tokens to process next. It's like teacher picking their student. Token choice routing, each token decide upfront how many loops it needed. Expert choice is more efficient but harder to train. It needs trick like auxiliary loss to avoid leaking information about future tokens. Token choice is similar but struggle with load balancing. MOR actually support both, and they explore these deeply in the paper. Now this is the time where we talk about the KV caching, and because storing all these attention keys value is what kills your memory. MOR uses two innovation here: recursion wise caching, that is only store KV pair for tokens that are still active, simple and efficient. Recursive KV sharing, cache just the first recursion and reuse it across all other. So there is a trade-off. Sharing KV pair can slightly hurt performance but slashes memory need. So you pick what matters more, quality or speed. So now let's talk about the results. The author ran MOR from 135 million to 1.7 billion parameter scale, and the number speaks. Under the same compute budget, MOR beat vanilla transformer in few short tasks, train faster, uses 25% less memory, and boost inference throughput up to 2x. And remember, this is not a model trick, it's an architecture level gain. Best result, expert choice routing plus recursion wise caching, that combo just work. So what makes MOR trick? Team ran ablation study to find out the middle cycle parameter sharing gave the best result. The linear router with sigmoid activations outperformed deep MLP simple, which is better. So the coolest part, tokens with more semantic weight like confident or drugs actually route deeper. MOR learns to think deeper about more meaningful words. So what's next? The future direction. The MOR for multi-modal vision, speech, video, integrating with sparse execution and quantization, scale up to 10 plus billion parameters. But even as this, MOR is a big leap. True hybrid parameter sharing, adaptive compute, and smart memory. It just does not scale model, it rethinks how they compute. And that's it. It mixture of recursion, a recursive transformer that learns how to deep think per token, and it might just make large model feels like a whole lot bigger. Thank you.
About the basics of making an agentic graph. So till this point, we have learned how to execute a simple graph, state management, memory management. You can follow the previous session if you're new to this channel. Now, what we are going to do is create an agent and give it two tools. First one is calculator one, a calculator which takes a string literal and do the simple calculation. This is our custom tool, and one tool which is from LangChain community, DuckDuckGo, that will do internet search for us, and we'll define it in a tool array, and we'll just have to call dot bind tools on the Azure Chat OpenAI model. So that way, what we are saying is we are passing these two tools, and our model should have this information. Our state is very simple this time. It only contains the messages, and subsequent messages will get added as we receive them from multiple stages. So it's a very simple model node. It takes the state and it runs the state. It takes the state message, invokes our model, and then it returns the message, whatever be the response. Then it builds the state graph, add the model node, then it also add a tool node. See, this is important here. The previous code, it was same, just that we have not added the tools as an explicit node. Now you'll see what is going to happen. We are going to start and go to the model. Start node goes to the model, and then there is a conditional edge. Model can go take the route to the tool condition, and then tool can route to the model. So this is where, if model thinks that it needs to pick certain tool, then it is going to take that route. Then from there we'll build the compiler, and this tool condition you can import from the LangGraph pre-built tool condition. From there itself you'll get the tool node. From there you compile this, and let's ask the question as how old was the second president of India when he died, and let's run it and see if we are getting the response. The second president of India was Dr. Sarvepalli Ramakrishna. Was born on 5th September. He died on 17th April 1975. Now, this is information that we got. And this is how, because it has bind the tool, it had called the DuckDuckGo to receive the information, and then from that information it constructed a final answer for us. Sorry for that. Now you might be asking, what if I want to force my model to use a certain tools whenever it receives a query? So because we want a control over calling the tools. In that case, we'll need to do some modification which we'll see. So let's define. We'll keep everything same, and let's define of we'll define a function which is, let's name it first model, and we'll pass this state, and it also returns the state, and we'll extract the query. What is the state message? The last one, the context, the content of the last message. So it could be the AI message or human. It will be, in most of the cases, it will be AI message. Then we can enforce here search tool call, and then we can make a tool call, and we can force it. So let's first import this. I think it will be you can find this tool call in LangChain core messages. There is the tool call, and this is enforcing it to make a tool call, and then in the tool call we'll have to define which tool. So we have our tool as DuckDuckGo search, and in the arguments, what it takes the query, and we'll pass the query, and second thing that we need to pass is the ID. So let's give it an ID is UUID 4 dot x. Perfect. And now return the message as AI message. We'll also need to import. Let's go there, AI message, and when we are making the tool call, since we know what needs to be passed, we can keep the context as empty, and there is one call tool calls. Here we can pass search tool call. Perfect. Now when we are going in the state graph, we'll need to add one more node as builder dot add node, and here we can define first model as the first model, then model node, tool node. Start will send this to first model because we want to enforce our model to make the tool call. Then the first model will go to tools node. So here we are removing the uncertainty. Now it will be a simple edge. First model will go to tools, and then we can build a dot add conditional edge. Here we can pass the model or tool, condition, and then tool will go to the model. This is going to build it. Now this time when we are calling this, hopefully we'll see it. This time it has used the this time it has called the tool, but it was not able to find results. So what happened is, like, for this query it was not able to find any answer. Let's ask another query. Who won the last India versus Pakistan match? Today is date, time, dot, date, time dot now. Let's see if it gives an answer. So another, also, do you want the result of the match finish? Which do you prefer? So it has taken it. Tool message is February 2025. Tried deleting all. So it's hallucinating a bit, but yeah, it's trying to call the DuckDuckGo. This is what brute forcing is. Here, what the important things is, we have not instructed the model how to use the tool properly, and that's why it is happening. But just to give you an idea, like, this is how it's going to work when you're building an agent. But we just wanted to make you aware with the syntax. In the next upcoming session, we are going to do this full-fledged with in-memory vector store and many multiple tools for a model to select, and from there we'll carry on and we'll build our robust systems. Thank you. Hopefully our model does something. See, it is trying. Look, I am not touching any keyboard, nothing. It's trying to pick up the model. Some time, because it is about 300 lines of code right now. So I had recorded it and it become very long. So what I am going to do, I am going to explain you how it works, but make sure that you have coded along with me the data collection part. And now let's move to the training the behavior clone model. So we are going to use the PyTorch and sklearn the trained test splitting. So make sure that you collect about 100 episodes from this code, and once you have collected those 100 samples, training samples, pair of which is exactly the state and the action pairs, and then we are good to go with this. So I have defined a simple BC dataset class which has inherited the PyTorch datasets, because we need to define the length and get item attribute, like how PyTorch knows that what is the size of data and how to pick one of the data from your data set. So it is nothing, just the dictionaries, numpy arrays, and in here the dictionary is defined as state and action pairs with the same index. They are having the same index. So let's define the init. We'll pass the transition, state, action. Now for each transition we have saved the episode metadata. If you go here and let me show you where we have saved it. So if you go there, you see episode metadata we have saved, at what time we have collected that episode, how much step that was taken, total transaction, the frequency, and the seed value, because it is going to be, seed value is very important because that is what is going to help the gymnasium environment, the Mojoko environment, to create the same exact replication of that instance. So what happens is you collect the state action and then you populate your state and action arrays here. So this is what is happening, and then we are going to log the state action save. So both state and action are going to have same lengths, so you can just return the length of state, either the action as well. Get item I have already explained that they are the same thing, it's just the index. You just need to pass the index and you can collect the same data point with that, because they are paired data, both are having the same indexes. Now let's define a very simple 3-layer neural network. Let's pick one linear layer, and the activation function I'm going to use the ReLU. A dropout layer, a linear layer again, and again activation function dropout, and then finally we are going to bound the action to the help of 10H, and action dimension is going to be 4, which is XYZ, and open and close state. So that we have defined with the keystrokes. If you remember, we had captured these, and 2 more are also there, which is the opening and closing of clipper. And this is how we are going to learn a very small sequential model for now. We can make it more complex, but in my laptop this is going to be work smoothly while I am doing the recording. It's important. So as we need to now call the initialization of weight, and we can apply the init weight. We are going to go with the Xavier initialization for weight and constant initialization for our biases. So this is done so that we have a smoother gradient descent. We can also play around with that. And this is the forward method, and in the prediction you have to project them to the floating tensor, all of the states, and then pass it to the forward layer while making the prediction. So this is what it is going to execute in the network, the forward class. So now let's define a function which is going to load the BC data. We have saved this data as a combined pickle. You can do that transformation, so it's easier to load in your training set. And then transition, let's pick all of the transition, and we can return the transition from here. Now after that we are defining the train simple PC, where we are going to pass the transitions, the epoch, the batch size, and the learning rate. We'll pass all of our transition from that loaded pickle file as the dataset, and then we'll train do the from skr train test splitting. It's going to split test and training set, and from that we are going to create a data subsets. So step 1 is to do the splitting and then create the subset. From there we'll create the data loader class, which ensures that since we have inherited the data, then we are going to use, we'll be able to use the PyTorch data loader class. Then let's define the model. The dimension of the state is 25, action dimension is 4. The optimizer, let's use the Adam optimizer, and the criteria as mean square error loss. Let's call our training loop for each epoch from the batch of the training set and action. Zero grade optimizer model is going to make prediction. Criteria, we are going to pass the action and prediction that is going to calculate the loss. It's going to do a backward propagation, and optimizer is going to take a step. From there we are going to also keep track of the training loss. Now we'll also do an eval from there, that from the test loader we'll do the same thing. It's just from the validation sets. We're going to record all of the losses, average train loss, test loss, and we are going to append it. And then this is the standard PyTorch way of saving the best test model so far, and we are going to print on every 50 steps what has been done. And then we are going to finally, when it is done, we are going to load the best model and then save it. We'll save this model dictionary, action dimension, train loss, test loss, and also the model pointer. Then finally there is one helper function which is going to plot the mean square errors and training BC curve. And then we'll also, once the model is trained, then what we are going to do, we are going to inject this the test sample into the environment and see if model learned something. So as we have done in the previous steps, from the gymnasium we'll bring the gymnasium robotics, fetch pick place dense v4. Remember that we are going to use the v4 version, and then we are going to inject the observation from the test sample. Same thing that we have done previously, calculating the desired and initial weights, and we are going to propagate all of this. This is the same thing, same code that we have done in the step 1. We are observing like is the current distance or what our desired state is met or not, and based on that our validation dataset is going to render the environment, and there you can see with your own eye if this is done properly or not. So now let's call our main function. It brings the transitions, it trains the model, and then it do the simulation by feeding back the train data into the your simulation in the PyMojo simulation, and this will do the end-to-end training of it. Let's start with training this code, see if it works. So if right now you'll see it's going for 1000 epochs. It's a very small model, and you can see that training loss is getting decreases, but it's a very small model. You cannot expect much from it. For quick tutorial it's fine. When you are doing your own implementation, you can go design a really complex model as well. So with that, we'll see how this model performed. If you can see, this model is quite underfitted. I mean, obviously it's a smaller, only three layer model, so you can see training test loss, they are not that much converging, and here from here you can do the improvement and make a complex model. Now let's see the injection step. Let's start the simulation. Hopefully our model does something. See, it is trying. Look, I am not touching any keyboard, nothing. It's trying to pick up the model. It wasn't able to do it in a finite step. Let's see if in this step will it be able to, but this much is still good. Like, it has learned to, whenever it goes close to the object, it's opening the clipper and all. But with more example, I have only recorded the 5 samples. You can do more, and So yeah, it's all about giving more time and compute. Your model will be able to learn. So yeah, thanks very much. In the next section, we are going to learn about the reinforcement learning. This is the behavior cloning way. Now we are going to learn next section, the reinforcement learning one, and where we are going to let our model to pick its destiny by its own. From the trial and error, it is going to learn everything. And thanks very much for learning. One of the very crucial part of reinforcement learning is the intimation learning, and your imagination is the limit from now. Thank you very much. Close this and let's move up. Perfect. We just need to. These two paradigms represent different philosophies. Reinforcement learning is about trial and error, where an agent learns by exploring and receiving feedback in the form of rewards. Behavior cloning, on the other hand, is about intimation, where an agent learns by simple copying the behavior of an expert. By the end of this tutorial, you will understand not just what reinforcement learning and behavior cloning are, but also how they are used in real world, their strength, their weakness, and maths behind them, and how can we even combine them. So first thing first, what is essentially an uh, reinforcement learning? So let's start simple. Imagine teaching a dog to fetch. Every time the dog brings the ball back, you give it a treat. If it runs away, you give it nothing. Over time, dog realize that fetching leads to reward and ignoring doesn't. So this is the essence of reinforcement learning. Now, the core component of reinforcement learning is typically framed as Markov decision process, which I'll explain. We'll come to this graph later. So let's understand first thing is which is called the Markov decision process, or in short form we can say MDP. So it consists of, first is state, which we'll denote as at X, then the action. This is the it represents the situation the agent is in. Action represents the choice the agent can make, and then third is the transition function, which will represent with T the probability of moving to a new state given an action. So we can also represent as P T given A. So now fourth thing is the reward, which will represent as R. Thus the signal, this is a signal that's telling agent how good its action was. And then fifth, we can define policy as pi. So this is the strategy how the agent chooses the action. And then finally, we can say the value function. So this is the estimate of expected long-term reward. The here the goal is to learn a policy pi, we need to learn it such that it maximizes the expected cumulative rewards. So what we want to maximize it, the rewards. We need to learn a policy that maximize the reward. So if you see, if we look at the diagram here, the representation is like we have an agent and it interact with the environment by taking some action. For that it gets an reward. So this is what will go on here. So formally, if we see what is happening formally, so the return form from time step is, so from any time step we can say the return, we can define it as the sum. We'll assume that it takes an infinite steps of r t plus k plus 1, where this gamma is a discount factor. It can be between 0 to 1, and it tells us how much we care about future rewards compared to the immediate ones. So this is where you can relate this with the learning rate as well, if you know the deep learning. So what is here, the agent wants to find a policy pi that maximize the expectation return. So in terms of the maths, this will be written as, given this state, what is the expected GTS for this state. So this is how we have defined the term that we are referring. The agent wants to find a policy pi that maximize expected return. Now let's define the Q function. So Q function here, then the Q function of pi, you getting the state, performing the action, is the expectation of the reward gt by s of t, which transition to state by taking an action as a. Now will this is how the formulation will work. We will be also going into the real world implementation, where we are going to define our own, we build our own network to do this learning. Here the important thing is to know what is happening. So you just need to ensure that you understand the MDP, Markov decision processes, and from there we can now look at the learning methods. So how do you actually learn? So there are three major families of algorithm. The first one is the value based method. Second one is the policy based. And third one is the actor critic. So here in the value based is the one that we discussed above, is the Q learning, and Q learning usually has this updation rule: state and action will transition from state action, and we can say plus an alpha time plus gamma maximizing the Q S dash A dash minus the Q state of Sn here. So these are the transitioning states, and it is used in early success, like uh, so uh, the algorithms, once again, like playing an Atari game. So this is where the Q learning would be used, and let's wait it for loading. Now the next one is the policy based methods, where where what our objective is to understand, like, how directly optimizing the policy, for example, and it will be defined as a gradient, let's say j of theta, and expectation theta, let's log theta, action given state, and then q. We will go more deep into this, what these terms mean and their actual meaning. And the the third one is the interesting one, which is called actor critic method, that combines both actor decision and critic evaluation, which is used in advanced robotics. And we are also going to code one of a robotics example, where we are going to teach a robot how to pick and place an object from a position to its desired position. So now, what is there is also thing called deep RL. This is what we are also going to do when we add a deep neural network. The reinforcement learning becomes even more powerful, so, such as deep QNNs, DQN, we can also say it. So, like, if you have also heard of the AlphaGo, which is reinforcement learning plus deep learning, and it has also defeated the world champion. And also the OpenAI DPO PPO, the scalable reinforcement learning for complex tasks. So their applications are in, like, robotics, walking robot, drones, and game playings like Atari, chess, and Go, finance, trading strategy, recommendation system, AI alignment like RLHF for ChatGPT. Now, the second part, which makes it even more interesting, is the behavior cloning, which is called BC. Now, here we have to flip the perspective. Instead of letting the dog figure it out through a trial and error, imagine showing it again and again how to fetch. The dog just intimates you. This is what is behavior cloning. So, the formal definition in terms of mathematics, we can write. So, we collect expert demonstration pairs of state and action, which formally we can write as, so let's say for data set D, which has this pair state and action, and we can obviously can go in, if n is a large number, that's really good. So we have some finite amount of data set pairing of state and action. We trained a supervised learning model phi theta to minimize the loss function, which is a function of state, and it outputs an action So this is nothing but, if you know this mean square error, we can also use it. This is nothing but supervised learning on state action data. So there are many algorithms that can be used here. The first one is the BC, trained directly from demonstration, and there is also called Dagger, dataset aggregation, which is a fixed distribution shift by querying expert when agent deviates. So then there is other BC with deep learning, train a deep neural network on large demonstration of a dataset. So this is what we are going to do in the coding section, in the next section. Here the application are self-driving cars that are trained from human driving data, robotics that teaches arms to assemble the object by intimation, and like now the here the limitations are also there. So the main limitation is the generalization of problem, because it fails if it encouraged a state that was not in the dataset, and we need a large high quality demonstration. No exploration, so I mean it can't adapt to an unseen cases. So here, so what's different between now, we can say, the reinforcement learning and behavior cloning. So reinforcement learning is pretty straightforward on based on the rewards, where it is behavior cloning is based on the expert data. And thus in reinforcement learning we do exploration. Here we don't do such things. And in terms of data efficiency, we can say reinforcement learning is data hungry, and it is a more efficient process if we have few sets of example. And in terms of reinforcement learning, we can say it is a generalizable model. Generalization is easy, and here we can see it is weak. And application could be robotics, finance, games, and here behavior cloning would be driving cars, intimation robotics, imitation, sorry. So the biggest drawback of reinforcement learning, it is slow and unstable, but and behavior cloning, it fails on unseen data, unseen states. So in practice, we often combine both of these approaches. So here what we are also going to do is the reinforcement learning with demonstration, which is also called the warm start policy with BC, and then refine with reinforcement learning. So it's an inverse reinforcement learning that recover rewards from demonstration, and we can also say it's a human in loop RL that combine the imitation plus exploration. So to summarize, reinforcement learning is about learning from interaction and reward. BC is about imitating an expert. Each has its strength and weakness, The future lies in the hybrid method that combines the best of both. When you look at the modern AI system, from the robot to large language model, you'll see both RL and BC are at work. These methods are not just theory, they are powering the next generation of intelligent machines. So, this is the theory that we require to understand what is going to happen in the coding section, because there we'll directly deep dive into the coding, and having this prior information is required such that you understand what is happening when we are developing the PC and the RL systems. So let's move to the next section where we'll start doing the coding. So now we are going to do the coding. Our first step is the data collection. First, we are going to learn how can we do the dataset collection for behavior cloning. So we are going to use the gymnasium robotics here, and we are going to use one of their robots, which is the task of that robot is to do fetch, pick and place, and this is I'm going to use the version 4 of that because it works perfectly right now. And what we are going to do with the help of Pygame, we are going to send our action into this simulated environment, and from there we are going to record this process, like the picking of the object and placing it on the required position. So first thing, we as an expert, we are going to do this, and we are going to record the state and action, and after that we are going to teach this to a PC policy model, and then the model is going to do the same thing. And then finally we'll close this off with training a reinforcement learning model, which will do trial and error and learn it by itself. And once we are done with, then we are going to the hybrid approach. We are going to take the PC clone model that it has learned, and from there we are going to do the warm start and then do the reinforcement learning. So first thing first, let's start with the data collection part. Let me zoom a little bit so that our code is visible. So make sure to do the installation pip install gymnasium, and once it is done, you can import gymnasium as gym, and you can also import the gymnasium robotics. This also you'll need to do the installation. Import numpy as numpy, because we want to store this data as an numpy array. And then also you can do installation of Pygames, which we are going to use it to send the action to the environment. That's also a pickle, and from datetime import datetime. So now let's define our key action, which is like we are going to map our WASD keys to the movement of plus X, Y, Z direction. So if you see what is it doing, it is doing a movement in X, Y, and Z direction. So let me zoom it a little bit. So you see, we need to map these things such that it reflects in the coordinate systems. So let's define the key mapping, just like in the games we are used to. So let's do that same thing. So this is what we are defining. Let's define a dictionary. So from pygame dot key small w, we'll define it as numpy as a action, numpy array, and here will do, whenever it says W, you should move X forward. So for X forward, let's define as minus 0.1, comma 0.0, comma 0.0. So what we are doing is we are defining this key coordinate like X, comma Y, comma Z. So this happens when you do the uh, key of W. Now let's define the opposite movement, which is the S key. So it should, in this time it should make plus. And now we want to move toward left. So for that we'll define the A key, and because we want to move the left, so it will be 0.0 and it will be minus 0.1. So this is the delta movement we have defined. It's a very small movement and it makes a lot more sense to take our little steps. And so let's paste this KAS D and then plus. Plus means it will go to the right. Now we need to define the up down movement. So for that we are going to map the Z and X key. So when you press Z, it is going to go on the top. So pygame dot key Z. Let's do one thing. Let's copy it. Z defined as minus. By this time you will be able to also get it what I am trying to do here. And X as going down. So let's define it here. Perfect. Now as you can see, we have done the mapping of movement keys. So now let's define a environment initialization function which is going to bring our robotics model here. So let's define init env and we can say gym dot register environment and we can say gymnasium robotics. Now let's create the environment as gym dot make. The name is fetch that it is available. Let's see. I'm just trying to see the correct value. So it is fetch, pick, and place. And V4. If you're going to use V3 right now, it is going to throw an error. So, but you can also try. If it works for you, that's fine. V4 works for me, so I'm going to stick with that. Render mode is going to be human because we are going to teach this. And max episode steps. Let's give this 5000 steps. And it is going to return the environment that we need. So once we execute this function, it is going to bring our robots in a Mojoko environment. So make sure that you have installed the Mojoko. For Mac, it's very straightforward. So you can come here, Mojoko, advanced physics simulations, and you can go to download section, and then you can download your required binaries based on the Windows, Linux. You just need to download and extract it. So assuming that you have done this step, then we need to define the teleops, which is transporting the operations and the state in via the interactions. So let's define. We can pass this as an environment, and we can pass this as a file path. So let's every time expert data.pickle, and we can define that we also need a sampling frequency, how frequently you want to collect the data. Let's define every 5 frames, and that's pretty much we need. Then what we can do, we can initialize our pygame. What this is going to load our key mapping, and we need to define the screen. So it is pygame dot display dot set mode, and we can define a 400 cross 400 screen. It doesn't matter, we are just using it to we are just using it to map the screen. We are not entering anything in the pygames. For that we are going to do the Mojoko. Let's also set the caption. So teleop fetch and place task. Now the next thing is we need to define a clock, because timing is something that we want to measure. So let's pygame dot tick, I guess pygame guess time dot clock, and we can measure the successful episode. This one says 0. Let's also see how many attempts we are taking, and let's also input the OS, because we are going to save the files. So let's define the folder name as output folder is expert demos, and we can make sure that this make directory, this output folder exists. Okay. If it is there, then do nothing, otherwise create it. So now let's set a seed value, so that we should, and now we are debugging, so we should replicate the environment. And once this is done, now we can enter into collecting the data. So let's define a convergence criteria as while successful episode is less than 1, which means we have not even collected one successful attempt. So till then keep running, and then we can increment our total attempt. So now we need to call our environment dot reset. What it does, it is going to give us, once we pass the seed value, it is going to give us the replicatable values of observations and information. So this will be useful. Like let's define a flag which will mark as false, which is a done state, and let's count the steps. And in the piece code data, we are going to store the data for episode. Now let's capture initial positions. This is going to be useful when we are training the PC model, and we can initial check position. So there is called achieve goal, and then initial, not the object but the target. Checked desired goal. So what we are interested is the the distance between these, the initial and the final desired goal locations. If they are within certain range, then we can say, yeah, we have placed the object exactly there. So while we have not even collected one episode, and we have marked the as while not done, meaning now we can enter into grabbing the object. Then we can define the action as numpy dot zeros and with 4, and we can define the t type as by dot float 32. So for event in pygames dot event dot get, let's get all of the event. If let's handle a base case where if an event is an exit event, you need to make sure that there is an exit event that which quits the game. So if pygames dot quit happened, then we can mark the done to be true, or if game dot type is equals to pygame dot key down, and there is a control C. If we press event dot key equals to pygame dot key escape, then we are also going to mark this done to be true, and we can break. Right, so Now we can collect the keys that has been pressed by the human. Pygame dot keys dot get pressed. Now we can see which key was got pressed, and according to that what data we need to process. So we can go for key comma data in key action dot items. So if key comma, let's make sure that the pressed key exists. If this key exists and this key in will also bound this to key w, the key of w, then we can copy that key that we have defined, key of s a t z and x. So up, down, left, right. Then we can action. The third is the delta, the till third value. So what we are doing here, we are setting the components directly, and then we can break. Because for that loop, we have captured the key. One thing I forgot was this. There is one more movement that this robot does. Is the gripper movement. Is the open and close state of this gripper, and we'll also need to define the keys for our expert. So what we can do this directly. If key is pygame dot k, let's define c for close, then we can define the action equals to -1. It's the inward movement, and L if keys pygame dot k will use open for, and we can just copy this, and instead of this one it is going to open the gripper. So once these things are clear, we need to get the next observation. So what we have done here, we have collected the actions. Now we need to pass this action to the environment. And then again collect back the observations. So it is going to give this next observation rewards terminated truncated in the info, because how much reward we are getting, if by taking that step we want to measure it. Let's also increase this step. Now we need to also measure the we'll also need to save these transition as it is happening. Right now, what we have done is collect the actions and then feed it to the environment back. So let's do one thing. If we have taken these steps, and how frequently, like there is way like you can do it on every steps, but this is going to explode your data, and we can define some precision like if it is the multiple, let's say every 5 steps, sampling frequency every 5 steps. If it happens, then, or if it is a terminated state or it is a truncated state, then we can capture the transition. So what we are going to save the observation directly as OBS, the action, and we can also say reward. And we can also, because it is going to be helpful while training the data with the current observation, what should be the next observation. So we will pass the next observation and the done state. Like by taking this observation, is it done or not, so that we will be able to know with the truncated or the terminated state. We can define, let's also save the info. Now, and if we can save this much, and if we want exact copy, like for training the neural network, then we can use the exact value as well for the network. For now, let's only copy, try to capture this much. So the episode data dot append, we have defined an array, and we can push the transition inside that. And then once this is done, we can define the observation, the current observation to be the next observation, so that we move to the next stages, and then we can render the environment for 1, and we can increase our time by 20 steps. So this is the frame rate actually. For smoother control, I have made it to 20 frames per second. And now what this pipeline is, what it is going, as a human interacting with this environment, it is going to capture everything, and it's going to save everything in an episode data. But we don't know when to stop. Meaning when we are doing the rendering process, you'll see we have reached the object, but there's no way of doing that. We have achieved the desired criteria, so we'll have to write the logic for that. So we can define a flag, episode successful. Let's mark this as false, and then we can define a current distance, numpy dot linear algebra dot normalization, sorry, norm, achieved goal minus desired. This is what we are going to measure. So if the current distance is very less, let's say 0.05, that means we are really close to the object. Then we can mark this episode successful to be true, and we can also mark the terminated to be true and done to be true. So if, let's say, if the difference, because we are taking the norm, so this can also, like, we can also do it with reward as well. So let's say our reward, our rewards is right now 0.0. Like, we this is a high reward case. We can mark this to be successful, terminated to be true, and done to be true. Or if it is a case of terminated or truncated, then also mark this to be true. But if it is a case of terminated, then that case, let's also, for now, let's mark this to be successful, which means like episode completed successful, task is finished in the prior steps. Not, you need to differentiate, like when the episode is ended with the exceeding of time, like meaning in that time we were not able to, so we cannot like run, we cannot give an expert the whole day to capture this data, otherwise it will take complete storage of your server wherever you are running. So this is the case which handles it. So if we don't do else, then it's also fine. Now what we need to do is, if it is a done, and if episode is successful, then we can say successful episode as well. Like we have captured one data, success data, and then let's also capture the timestamp when it happened. Datetime dot the moment that it is captured successfully, then we can format that as year, then date, and on the hour, it's also a month, seconds, sorry, minutes and seconds. Then we can say episode data dot append. We can also append some metadata if we want. For now, let's leave it. What we are interested is, let's first save in a file. So in a separate file. It will be helpful to debug like what happened. Can you find the output folder slash episode, and then we can find datetime.now. Yes. Pickle. So with open episode file as write binary pickle.dump episode data, and if it is done, then we can break off this while loop since we get our successful episode. If that is not the case, then we can ask user press any key to continue to next. That is, we will prompt user to go to the next stream, and we'll just take an input so that Pygame environment is compatible with that. So now let's go pygame.time. Let's also wait for 1 second before we transition to the next step. Finally, when all of these things are done, we'll close this environment and we can pygame.quit such that our environments are closed properly. So now let's run this finally. We can get the init environment, that function that we have defined, and then we can call our deliops collect. We need to pass the environment and the sampling frequency. If you don't pass it, it's still going to take 5. So after everything that we have done, we can run this code and it's going to show us. So I was doing some debugging and I have added some debugging statement. There was one error. So hopefully now we'll run this and that error is gone. Collect data. So yeah, let's collect every 5 steps. So it's asking for seed value. So now what you can see, I am moving this robot with my, see, I have closed the, I have opened it. Now I can close the gripper and just the way we have written the code is we have to like continuously press the close button, otherwise gripper will open. We can also fix that, but for now it works, and we were able to save the expert demo here, and it was really cool doing that. Now before moving to the next part where we are going to train a BC model, what I'll suggest is you run this code and record multiple of such expert examples, a lot of examples, and then we are going to train a neural network from our dataset. It is going to do everything that we have done. So for example, it has completed in 416 step. It has collected 83 transition, and we can, let's do one thing. We'll also run it one more time. Let's keep this seed as 3443. This time it is somewhere else. So let me hide this menu. Let me also. So what we are going to do, it's not visible. Yeah, we can go here and there. Let's see, we can close this and let's move up. Perfect. We just need to bring this to the red position. Finally, we did it. And this time it's saved with different seed value. And you can see as we are doing this, the reward is getting increased because we are getting very close to the desired position. So yeah, hopefully you will be able to replicate this same thing. I'm going to push the same code onto the GitHub, so you can start doing the collection, and after that we'll train our own PC network. Thank you.
Neon whispers hum through the air. Circuits dreaming, they're everywhere.
Good thing for you. What if you don't have to click, scroll, or scrape? It just did reliable on demand. Today I'm walking you through browser use, a lightweight automation toolkit powered by AI and Playwright. In next few minutes, you'll see how to go from fresh project to fully autonomous agent that can browse, interact, and extract information using only few lines of Python code. Now, so browser are the center of how we do the interaction with web. Everything from web apps, dashboards, SaaS tools, all lives inside your browser. Yet, despite that, the tool for automating them have often clunky, verbose, and brittle. You end up writing tons of boilerplate, open windows, wait, locate element, click bars. What if you could treat the browser more like an agent? Ask it to go find something, click this or that, extract data, and it handles the